A very good morning to all the participants of AICT sponsored 1 week online short-term training program on water quality complication, restoration and environmental conservation of existing water bodies, Module 2. So we are at the day 4 and the first session will be taken by Dr. Mahesh Kumar Jat sir. He is the head of the Civil Engineering Department, Malaviya National Institute of Technology, MNIT Jaipur. He is a postgraduate from MNIT Jaipur and a PhD from IIT Roorkee. The major areas of his interest are urban hydrology, hydrological modeling, land use, land cover change modeling predictions, integrated water resources planning and management, climate change, their impact on water resources, development of integrated water management model, and land use, land cover change patterns, its impact on climate change, optimum land use planning, application of geospatial technologies like remote sensing and GIS. He has in all 54 publications in journals, which are international, 4 contributions in the form of books and book chapters, 56 contributions to conferences, and with an H index of 16 and I-10 index of 26, he has citations of 1751. He has supervised 9 PhD students which have been awarded and 6 are in progress. He is also a supervisor for the MTech students, in which 34 students are already awarded and 3 are in progress. He has a lot of esteemed research grants from AICTE, Ministry of Water Resources, Government of India, DWDSC, Government of Rajasthan, NDMA, Jawaharlal Navodaya Vidyalaya, Pauta, World Bank sponsored projects from and also projects from DST, MOWRM, which is from Government of India. He is a member of professional societies like ASCE, IST, IWRS, ISRS, ISX, and so on. With foreign collaborations from UTS, Australia, KIT, Germany, UCSB, and so on. I welcome you, sir, on behalf of the Civil Engineering Department of IPS Academy, Institute of Engineering and Sciences, Indore. I am highly indebted and honored by your presence, sir. I request please start with the session, sir.
Thank you, ma'am. Okay, so please, ma'am, allow that presentation to share.
Yes, sir.
Yeah. So first of all, thank you very much for inviting me, madam, and I will be happy, really happy to always for discussing the topics which are really very relevant and very important for our society. So water is that is a very important area, and so I'm starting my talk, and that is on integrated water resource management issues and challenges. Okay, so I would like to request all participants that please feel free to really interact, because always the discussion in interaction mode is more beneficial as compared to simply one way you can say instructions. Okay, so thank you very much, ma'am, and I'm starting presentation. Hope now the slides are visible.
Yes, sir.
Yeah. So good morning to all, and I'm just talking about water resources management, the different type of aspects of water resource management. What are the issues and challenges? You see, the water resources is very critical for our life, and that's why it need to be managed, because in the worldwide, it's not limited to our country. Worldwide, we are facing variety of, you can say, critical issues related to water resources. Okay, somewhere we are experiencing floods, somewhere we are experiencing droughts, somewhere we are experiencing a lot of contamination in water, somewhere we are experiencing a lot of scarcity of water, and in urban areas specifically. So that's why its management is really, really critical, because total amount of water that is available in the universe, it is constant, okay, and it is changing the forms from one form to another form. So what are conventional, you can say, water management approaches, and what are now evolving water management approaches? We need to be, you can say, implemented, okay, or considered for efficient or sustainable water resource management. So I think if you look at it, the United Nations Sustainable Goals, water resources related topics are very prominent, and they have basically emphasized on different aspects of water. Okay, so that's why it is a very critical element. And so I'm just discussing broad contours of like what is conventional water management practices we are following, and what are the evolving approaches of water management. And then I'm presenting a case study of integrated water resource management, okay, that we did in for a basically urban area. You see, in more and more, if you look at it, in coming future and presently also, around more than 50% population is residing in urban areas. So our demands of water for water supply and any other industrial many applications, it is concentrated in urban areas. So the water resources related aspects in urban areas, they are, you can say, very critical for around 60% of the population. Okay, so I am discussing that integrated water resource management case study for an urban area. Okay, so please feel free to discuss. Okay, so just look at it. Water resources, as we know, all we are aware that is very important commodity, and it is very available in a very limited quantity. And nobody knows better than us in Rajasthan that we you can say struggle with availability of water resources, and we understand its really importance and its proper management. So look at it. Our concern starts with the uses. When our applications uses are limited and we don't find sufficient amount of water for different applications, we start complaining. Okay, so that availability means getting water is not alone a sort of important issue. From where we are getting water, what are the different type of sources, what are the different characteristics of those sources, okay, and what are the other type of infrastructure issues that are needed to, you can say, supply water from different sources to different users. So all this, the whole system, this is a complete water resources system that need to be looked into, not as single aspects of water resources management. So water resources systems, you just look at it. Okay, so overall, for a water resources system, there are three components, basic, you can say, components. One is water demands, then there are number of sources, and we need to create a system so that water can be tapped from the different sources to satisfy the different demands. Okay, so this water supply system is really, you can say, very critical. And here this is we play. So management is need to be done at all levels. It need to be done at a demand level, it need to be done at supply level, availability level, as well as your systems. Okay, so these are the three basic components of a water supply system. And just you imagine the broad categories of available water of different sources is surface sources, groundwater sources, other type of marginal sources nowadays, like you can say the treated wastewater, okay, storm water. So these are possible or potential sources. Okay, then on demand side we have variety of demands: domestic, industrial, institutional. Okay, so a lot of other type of demand, fire demand, lot of other type of demands are there. And to mix match all these two options, we need a system. Okay, the system is comprising of our policies, water allocation policies, the water resources related facilities, infrastructure things, okay, their operation rules. So that is whole system, and the system have its own, you can say, characteristics which are variable in nature. Okay, the economic factors are also influencing the systems. Okay, so that is system variables and economic, you can say, considerations are there with the systems. Okay, so demand side, demand also have the different sort of characteristics, like demand for the different users, they require the different quantity of water. And nowadays, even we are requiring different quality of water. Like for potable applications, we require particular quality of water. For industrial application, we may compromise with the quality. So different quantity as well as quality of the different sort of, you can say, users. And similarly, the source side, they have the different characteristic. Different source have different availability with respect to space and time. They have different sort of constraints. They have different type of quality. So they are source characteristics. Okay, so source and demand characteristics, they need to be integrated into a water management system, a sort of system. Okay, and through that system, you need to make optimum decisions. I hope my voice is audible. Okay, so it means your sources, one part, demands, the system, water supply system, water resources system. Okay, they need to be integrated into a some you can say management system, so that we can make optimum decisions, okay, of usage of water, satisfying all other type of requirements, like satisfying environmental demands, environmental considerations, satisfying your user demands, restricting pollutions. Okay, so these are the whole system. So that is the holistic view of sustainable water resources management system. Okay, so this is the ideal situation that we need to consider all, but this is the basic structure that is available as far as the water resource management is concerned. So formally, we can define the water resources management can be defined as a mix of activities, measures, and techniques employed for optimum utilization of available water resources to achieve sustainable economical, social, and environmental objectives. Okay, so now look at it. Means available water resources achieve sustainable economic, social, and environmental objectives. So there's no alone one objective, that we need to maintain our environment, we need to maintain our sociological aspects and economical sustainability. So that is all activities, techniques employed, okay, for optimum utilization to satisfy these goals. That techniques or tools that combine together, they call water resources management. Okay, so the challenge of effective water management can be really can be seen as an opportunity as well. And sometimes when we are forced to adopt certain measures, okay, sometimes they are good. Like in during the scarcity, okay, you need to look at it, the different sort of options of management, different sort of sources. Okay, so and that is the requirement. Whatever the source which are available, if at a particular place, if it is available, we need to optimize it, we need not to waste it. Okay, because the water is available in the limited quantity, and in worldwide the majority of water demands are for irrigation, maximum demands are for irrigation. And look at it, the efficiency of the irrigation systems is very less, around 30-35%. Okay, so that aspect is also, we need to consider that we need to employ proper technologies, proper tools to enhance the efficiency of irrigation. Okay, so the whole gambit of, you can say, the areas and the options and tools that need to be considered for water resources management things. If you look at it, the conventional practices, everybody is knowing probably, just I am flagging it, that the conventional techniques of water management, okay, presently what we are following, if you look at it from the last few decades back, okay, our water supply management, you can say, is involved nothing but supply management. Means as and when the water demands are increasing, we are trying to identify the new sources, and we are tapping those sources to satisfy the needs. So means one aspect we people are considering so far. Okay, so basically, and in that also we are trying to tap first surface resources, and if they are not meeting demand, then locally we are tapping groundwater, and if that is not, again it is not satisfying the demand, then we are importing water from the distant sources. So essentially this is what basically present water management practices. Okay, so it means more and more water is need to be tapped and need to be supplied to satisfy the demands. So traditionally, water management includes only supply management. With increase in water demands, water supply is augmented by tapping of new sources, or even when the local sources are exhausted, we can tap, we can import the water. So this is a general practice presently what we people are following in most of the areas. Okay, in our country as well, we are following this only. Like I can give the example of Jaipur city because I belong to Jaipur city, and look at it in long back in 70s and 80s. Okay, the water before that the water demands of Jaipur city was basically fulfilled by a small lake that is available in Jaipur, that is Mansagar Lake. And after that, once it was exhausted, then the new options were groundwater was tapped, and in 80s, water was, you can say, imported from a nearby lake that is basically in around 25 kilometers away from Jaipur city. And that place is so, that lake was so big that in 1981, in first Asiad Games, okay, we have a boat competition in that lake. Okay, so we were using that water. So over the period of time, as and when the demands were increasing, okay, and some local catchment interventions were made in that Ramgarh lake catchment. So now literally there is zero droplet of water in that lake, that Ramgarh lake. It is completely finished. So after that, then we have drilled a lot of tube wells in Jaipur city, and in last few years, before like 15 years back, a complete groundwater system was exhausted. Now the whole groundwater in Jaipur city and surroundings in dark zone. So means there is no water available that can be drafted. So before 15 years back, then we started thinking that okay, what we can do. Then authorities they planned to tap water from another, you can say, river, that is Banas. And on Banas river there was a dam, Bisalpur Dam. So they have prepared a project and implemented it to implement the basically that water supply project from Bisalpur. Okay, so Bisalpur, so it is around 150 kilometer away from Jaipur city, and its catchment is away from Jaipur. Means Jaipur and surrounding area doesn't lie in the catchment of Bisalpur Dam. Some other areas of Chittorgarh and some other parts are. So now we are transferring water from Bisalpur to the Jaipur city, and still in the last 10 years now it is rationing is going on, the water, and from the Bisalpur as well we are not able to satisfy all the demands. Now at the government level they are thinking to connect the Chambal river with the Banas. Okay, they want to bring water from the Chambal to Bisalpur, then from Bisalpur to Jaipur city. So the same situation is, I think, is we people are following throughout the country. Okay, and in many countries of worldwide as well, the same sort of supply management. So this is a present water management scenario in our country, that we are following only supply management aspect, and we are tapping more and more water from different sources, okay, to satisfy the demands. So just imagine, is it sustainable management strategy? Okay, like for Jaipur city, once that Bisalpur goes, from where we'll bring the water? Okay, if Chambal is failed in some year because catchment is lying around thousands of 500 kilometers away from the Jaipur city, so it means what we people are doing, we are inviting catchment problems of a distance place to the Jaipur city. So whatever, if tomorrow there are some problems in catchment of Banas, Jaipur will be affected. Something is happening in the Chambal, Jaipur will be affected. So this is the basically situation. So this is the present water management strategy that we people are following. And I think this is not a sustainable. This is at all, this is not a sustainable way of doing it. Okay. Then in the conventional management practices, basically our focus is mainly on satisfying the demands. Okay, whatever means it is there, and our dependency is growing on adjacent systems. Okay, and we are working. Our management strategy is considers individual hydrological cycle components, and they are managed separately. Like, just imagine that in all throughout the country we have the different departments. We deal differently with the stormwater that is considered as a flood nuisance in the urban areas. Okay, and all the areas. So that is a sort of flood. So we are wasting the stormwater. Wastewater is again a nuisance. Okay, we are not treating, partially treating. It is discharged in water bodies. So that is not used. Its quality is deteriorated. It is discharged in rivers or surface water bodies. So they will be again polluted. Okay. So and our focus means are dealing with all the different components are different. Like, to deal with irrigation, we have separate department. To deal water supply, we have a different department. To deal with the wastewater, we have different things. So there is no means we are managing individual hydrology cycle components separately. Okay, and such a system where we are following only supply management. We are you can say increasingly dependent on adjacent catchments or systems. We are managing individual components of hydrological cycle. This leads to such a management scenario. This leads to a variety of source and sink problems. Here, source problem means the problems related to sources of water resources. Sink means wherever we are disposing the water, that is the sink problems. So we are creating a lot of source and sink problems because of such a measurement system, which includes water scarcity, increased wastewater, pollution of receiving water bodies. Okay, groundwater, depletion of groundwater, severe conflicts among rights among competing users. Now just imagine, just for example, we are transferring water, importing water from a certain distance. So local peoples from those areas, they are making complaints that we have first right, we should be given water first, then you should transfer it. Industries are complaining that we are not getting water. Okay, and if they are supplied water, the civil society says that the industries are basically supplying. You are supplying to the industries. We are suffering. So a lot of conflicts are so such a system is leading to a lot of, you can say, source and sink problems. Okay, and a lot of conflicts, different type of pollution and all. So in the conventional system, water supply was also evolved because water was initially because demands were less, and such a supply management system was evolved because demands were less and water availability was more. So always we try to, you can say, choose a simple option. So that was the reason that it has evolved. Supply system is evolved because initially lot of water was available, demands were less. Okay, and but later on this has changed, and because of supply management, always we try to create centralized infrastructures. Just like we create big water supply systems, like from reservoirs and systems. So big, you can say, your intake works, then pumping, then centralized distribution systems. So sort of centralized, you can say, system was developed. Okay, and so centralized system for water supply, centralized system for wastewater collection, is treatment and disposal. Okay, and in conventional water management practices, all these decisions are made on short term. Just like in Rajasthan, we see whenever during summers, whenever demands is rising and the sources are depleting. Okay, more and government dig more and more tube wells in spite of dark zone. Okay, and they supply water from those sources. So the goal is short term. So these are the present situation and the conventional water management practices which people are following presently. Uh, Please feel free to discuss. Okay, it would be good that we should be discussing all these things in interaction mode. Okay, so just look at it. And water resources system, you see, Nowadays, around 60% population is residing in urban areas. So that's why urban areas are more critical, really more critical. Okay, because a lot of peoples are under risk in those areas. Okay, so water management system or water system in urban areas is more complex as compared to rural catchments. Okay, and because of continuous increase in population and water demands, concentration of peoples in a small pockets, so density is very high. Heterogeneous water demands means heterogeneous means somewhere you can have industries, somewhere you have institutions, somewhere you have need the fire demands, okay, and of the different quantity and quality. Then heterogeneous commercial activities, very and dynamic land use land cover. Mind it that your area is changing daily in urban area. A lot of pervious areas they are getting into impervious one, so they are affecting their hydrological cycle and their components. Okay, wastewater, a lot of more and more wastewater is generated, so that wastewater need to be treated, need to be disposed safely. But that is happening or not happening, that is again a question. And when we follow the supply management system, then this wastewater will increase in proportion to the water supplied. So again means we are solving one particular problem and creating another problem on the sink side, where we're generating a lot of then a lot of water pollution is taking place. And when we are following such a system, you see, when your demands are increasing, to satisfy demand, you need to tap more resources, you need to create infrastructure. When you create a supply infrastructure, there are a lot of ecological disturbances are taking place in urban areas. आप देखिए nowadays you can find everywhere roads are dug, pipelines are laid, and new you can say every year you can find the new things are going on in that particular area. So that leads to ecological disturbances, lot of ecological disturbances. So urban area is nothing but it is characterized by clustering of peoples in relatively smaller areas. Lot of pervious areas are getting into improvisation, dynamic land use land cover, okay, dynamic conflicting water demands, multifunctional usage of water, lot of industrial activities, a lot of human interventions are there. I'm just giving you a picture of urban because you see the more number of people are under risk of related to water resources stresses. So just imagine in 2008 around 50% of world's population was residing in urban areas, and by 2030 it is going to be around 60%. This is the data from the UN. Okay, so around 60% of population will be residing in urban areas by 2030. A lot of migration is taking place from the rural areas to the urban areas. Okay, so sorry, something has happened. Yeah. Okay, so around 2030, it is will be 60%, and that thing is going on. And I don't know whether it will stop at some point or not stop, but that migration is going on at a big way. This is just a data. Just look at it. This is again a data, UN population division data. Okay, like in 1950, the population of New York was 12,339, and see the New York. This is in thousands. Okay, so thousands. So more number of cities. Just see the number of cities which are crossing. So this is in population in millions. So just imagine that there was a one city in the millions during 1950s and 2015. There are more than 20 cities which are more than that. So this is the fast pace of population development in cities. See the population increase in urban areas, okay, continent wise. So everywhere this population is increasing very fast at an exponential rate. Okay, so that it means the urban management systems are more complicated in urban areas, and this is a big challenge in coming times. The water resource management systems in urban areas. So just look at it. How the current or conventional water management practices, how they are leading with a different type of source and sink problems. So just imagine that this is the present water management system, that increase in population, demands will increase, okay, and this increase in demand will be satisfied from the different sources, first of all, we tap nearby surface sources, groundwater sources. When these two are not sufficient, we are transferring water from the different sources. So this present system, okay, when you increase the supply, your discharge will increase. When you increase the transfers, okay, a lot of source and sink problems are created. So these are the source problems which possibly. Anybody want to ask some question?
So probably there was some disturbance.
Okay.
Any of the participants, if they want to ask questions, they can raise their hands or even type in the chat box.
So just look at the source problem. So such a management system, okay, different type of source problems which are like possible, and there you can say it is very much evident nowadays that from such a system we may have the source problem like depletion of groundwater, sinking of groundwater levels, subsidence. A lot of groundwater subsidence is reported in Punjab, in Punjab and Haryana areas. Then basically reduction in surface supplies and landscape disturbances. When you create infrastructure, a lot of landscape disturbances are happening. Similarly, the internal problems they will create, means within the system they will create like shortage of water sometimes in somewhere, flood nuisance. When you increase the population will increase, you okay, so a lot of conversion of pervious areas into imperviation. A lot of, you can see, flood discharge will increase, that will lead to flood nuisance, a lot of pollution, health problems and conflict among the users. So they are internal problems, they are source problems, and on the discharge side the sink problems are like increase in wastewater, sewage effluent, the pollution of receiving water bodies, increase in peak runoff and landscape disturbances. So this is the present case that we people are facing. Okay, and so the efficient management system is that we need to deal with this system. Okay, an ideal case is that we should reduce the imports of water. We should focus more on, you can say, our management should be in all aspects. Our management should be in demand side as well. We should not only manage supplies, we should manage demands as well. Okay, we should increase the water use efficiency. Okay, and that will lead to the less, you can see, discharge. It will reduce the sink problems. Okay, sustainability of your resources will increase, and these internal problems will also reduce if we follow the appropriate management strategy. Okay, so this is basically again the data from UN. So just look at it. Throughout the world, this is the scarcity of water. So physical scarcity, economical water scarcity, little or no water scarcity, and not estimated. So just look at it. Our country is, most of the part of the country is really lying in the physical water scarcity content. So it means we people are required more better water management systems, efficient water systems as compared to other type of other countries. Okay, so what are the solutions? What are the innovative approaches of water management? Okay, so these are the few principles, okay, or guiding principles that can be used to evolve a water management strategy that is sustainable. Okay, and so basically our strategy and the sustainable strategy should basically evolve around the safe access of water, sanitation and healthy environment. I think these are the three guiding principles, okay, around water management systems should be devised, they should be planned. Okay, so the first system is human dignity, quality of life, and environment security should be at the center of new approach. Means our water management system, it should not only handle the one part, means satisfying the water requirement. It has to ensure the human dignity through the proper sanitation, quality of life, that we should have the required amount of water in the required quality, so that there should not be any health problems. And simultaneously we should maintain the environmental security as well. We should maintain the environmental aspects as well. So this is the guiding principle that we should keep in our mind while following a certain water management strategy. and our system should be responsive and accountable to needs and demands in the local setting. It means our demand and you can say supply systems, they should be tailor-made considering the local aspects, local settings, okay, local characteristics. And we should not go for you can say import or some other type of resources unless local things are not you can say fulfilled. Okay, so that is the first guiding principle for a basically sustainable water resource management. Okay, and always we should also consider the appropriate economical opportunities from wastewater, like waste recovery, its uses for different sort of applications. And the second, the guiding principle is that good governance principles, decision making should involve participation from all the stakeholders, okay, especially consumers and providers of services. It means unless you take on board all the consumers, you cannot reform the system. You cannot implement any efficient water management system unless you bring them on board, stakeholders. So you need to consult really. So your management strategy, overall strategy should involve the service providers, okay, government authorities, okay, and stakeholders. Then only your strategy can be successful. Otherwise, it cannot be. Decision making at all levels we should be made based on the informed choices. Means we should provide options, we should provide choices to the decision makers so that they can take appropriate decisions. We should we can provide the incentives, okay, for different type of you can say services to implement them. Okay, so these are the second principle. And the third principle is waste should be considered as a resource. Okay, so far we are really considering like wastewater as a nuisance, stormwater as a nuisance, but these two are not nuisance. Just imagine that whatever amount of water you are supplying, approximately you are generating 80% of it as a wastewater. So mind you, this is a resource. If 80% of water is you are wasting for the different things, okay, from where you will get it? So this should be considered a resource. You should treat it, okay, recover the resources from wastewater, recycle it. Okay, so this is a big resource. Just imagine for a whole city, if you are able to even recycle 50% of water, how much your demands or your sources can be sustainable. And there are very successful examples are there where treated wastewater is implemented very well, just like in Singapore. Okay, in Singapore, basically they don't have water resources. It is a sea on the sea coast, and they don't have the conventional resources. So they recycle their waste to 100% wastewater. And just I seen it. Basically, you can find the water bottle that is treated just like even better than Bisleri. Okay, and they are implementing it. So just imagine that this is a big resource, and for the areas which are deficient in surface system or surface and ground resources, that is the big resource. So our management strategy should basically consider the wastewater as a resource, and its management should be holistic and form part of integrated water resources management. Okay, we should extract the nutrients which are available in the wastewater, and we should follow a holistic wastewater management approach. Okay, so the sustainable principle will help us, okay, in reducing, in promoting the efficiency. It will leads to the better environmental security. Okay, and basically we can save a lot of money as well by extracting resources from wastewater. Okay, so this is the third principle. And the fourth principle is that in the domain of environment, okay, sanitation problem, we should basically practice the sanitation practices in a decentralized fashion. Okay, so sanitation should be practiced at a household, community level, town level, district level, catchment and city level. Okay, and we should avoid really you can say increasing the wastewater by using the water based wastewater conveyance systems, so carriage systems. Okay, so that is another thing. Means our sanitation programs should be environment friendly. They should be tailor made for local conditions, local things. We should use better technologies for waste sanitization and reuse. So these are the different principles, okay, which basically we should consider while we are considering any management strategy. So evolving approaches, if you look at it worldwide, now what is happening, that what is evolving from the conventional water management systems, now we are more focusing on enhancement of water use efficiency. Lot of emphasis is nowadays is going on in enhancing the water use efficiency. Rather than supply management, we are also focusing on managing the demands. That how we can reduce the demands without compromising our hygienic needs. Okay, like what is my hygienic needs to fulfill a healthy lifestyle? Okay, how I can reduce the demands. So that is demand side management practices are also evolving nowadays. More focus is we should give on local available sources, local surface sources. Second priority should be given groundwater, then grey water, and treated wastewater. So this is a hierarchy that you need to integrate the sources, groundwater, grey water, and treated wastewater into a supply system after appropriate treatment. Okay, so this is minimization of energy use. You see, uh, we cannot consider water resource system in an isolated way, because we are consuming to implement a system to supply water from sources, to supply then treat it, we are consuming a lot of energy. Okay, so we need to consider in total, like we need to consider the interacting systems as well. Like your energy use is directly related to climate is changing, and the climate change is also influencing our water management decisions. So this is a whole web of, you can say, things, and we need to again consider the holistic things. So nowadays the systems, okay, which requires less energy, okay, they are evolving. That people are focusing on those systems which requires less energy. Then water management systems to evolve from single purpose to multi-purpose. Okay, we are like developing systems which are multifunctional rather than single function, like only water supply or only irrigation. Okay, and we are synergizing our resources from one system to another system. So this is another aspect that is evolving. And another important thing need to be done is our water management systems, they should be hybrid. Okay, it should not be entirely centralized, it should not be entirely decentralized. We need to follow a hybrid system which include optimum configuration of both centralized and decentralized systems, like different type of treatment facilities at the different locations. Like you can locate the small treatment units at the in locality level, okay, town level, even society level. Okay, like grey water recycling. So even you can say push for grey water recycling at even individual household level. And we did a study, and we came to know that if you implement gray water and rainwater, you can see uses at an individual household level, we can reduce minimum we can reduce our fresh supplies by 40%. So just imagine that is, if everybody start you can say implementing those things, we can save 40-50% of water. So and that reduction in demand is cascading. Okay, when your supplies demands are less, you require less supply. It means you need to create less capacity of your infrastructure for water supply. Similarly, you are generating less wastewater, that your treatment load will be less, you are consuming less energy, you are polluting less, you can say you are receiving water bodies. So there's a whole web of cycle that if we intervene at a one particular you can say point, it will affect all the aspects in a better way. And the grey water recycling is very easy. Even in a household level, means grey water means it doesn't have the fecal contaminants. Okay, so simply even you can simply use the grey water for flushing of your toilets. So in the flushing, you don't like you are not touching it. Simply you are pushing a button of like your flush. Okay, so simply even you can, by doing this, you can reduce the 40% of your water requirements by simply grey water recycle. So just imagine a small intervention, okay, it helps a lot. And nowadays more focus is there on demand management side along with the water use enhancement in water use efficiency. In many cities like in Australia, like Melbourne, Sydney, in many cities, government is running big programs for demand management things. Like they have changed the plumbings or water fittings in the houses on subsidy basis, and they are using efficient water fittings. So by using the efficient water fittings, even we can save the 50% of your fresh supplies. So a lot of efforts are going on. We for two industries, we designed their zero wastewater system, water management system with a zero discharge. Like one is ITC plant in Saharanpur and one is thermal power plant in basically Odisha. So nowadays people are coming up and the solutions are possible. Okay, there are very successful, you can say, examples are there where wastewater is perfectly treated, it can be recycled, and it saves lot of you can say waters. Okay, so this is like the comparison. If you compare the historic and evolving water and resource management practices, that the historically we are more focused on supply management. Okay, and now in evolving approaches we should focus on local sources. Our cost should be optimized. Earlier, we used to design such systems where cost of infrastructure is minimum, but now, because water is scarce, we need to focus our optimization things should not be cost, it should not be infrastructure, it should be water use, energy consumption. Okay, so our criteria are changing. Functions, earlier they used to be single, you can say purpose systems. Now it should be in evolving approaches, it should be multi-purpose systems. The configuration of water management systems, earlier, now conventionally we are following centralized systems, but for evolving approaches we need to follow the decentralized approaches. So this is how the better management practices and what should be the basic characteristics of better water resource management practices. Okay, in the hybrid systems, okay, in hybrid systems, water supply and used water, we need to separate it, but we need to use it. So hybrid systems, they are enabled by improved treatment technologies. Local water resources are becoming increasingly usable. Treatment systems are distributed throughout the area. Okay, and resulting is that we are managing the things at local scale rather than at a larger scales. By considering the big infrastructure things, we are managing them at a local scale. Okay, now there's a lot of focus is on their own green infrastructure. Green infrastructure means we need to create those water management systems where energy requirement is less pollution, okay, less landscape disturbances. So automatically they are fulfilled if you are managing your water needs locally. You are recycling wastewater, you are recycling grey water, so automatically your import or your surface supplies will be less, your wastewater generation will be less, you need to, your capacity of infrastructure will be less, so less, you can say, your energy consumption less, basically your energy demand. And similarly we need to implement the infrastructure, like a lot of groundwater recharge can be implemented through parking lots, through green spaces. So the areas need to develop in such a way that a balance should be maintained between surface recharge, groundwater recharge, and groundwater withdrawal that can be implemented through green infrastructures as well. Okay, and always we should use basically distributed system. The distributed system means our recycle systems should not be centralized. अभी हम क्या कर रहे हैं? We are people like we are collecting wastewater from the different areas and through the big sewer lines, and then we are treating it. Why we are following it? You can use the decentralized systems that in a local area you can treat it and recycle it, so that overall your system sizes can be managed. Okay, so we should in the recycle we use the in-home treatment devices sometimes like for grey water. Okay, to make it usable for you can say toilet flushing, you simply need basically sand filtration. Okay, or nowadays even we can treat like every house in urban areas probably now they are having the ROs, the mini you can say treatment plants. So we can use such treatment methods locally, and locally we can cycle. So that is another option. And separation of potable and not potable waters, we can implement the two pipe system in urban areas or in houses. We separate your potable like wastewater and grey water, and grey water can be recycled. We can okay, we can lay the two water supply lines. One is fresh water, another is for treated wastewater, and treated wastewater can be used for at least toilet flushing. Okay, so these are the few options which can be think of. And you see they may be slightly costly in some sense. Okay, but in a situation where we don't have water, really the water is scarce, you have to follow those things. Okay, otherwise, and if you are not following today, the coming generations will blame us, okay, for bad management decisions. Okay, so less distributed systems, they will lead to less use of precious surface water, less water treatment cost, less cost of wastewater collection and treatment. So this is the, you can say, indirect benefits from a better water management system which if we implement. Okay, so basically opportunities implementing integrated management system. Okay, it should be integrated. Your conveyance system distributed, treatment system should be distributed. Okay, and we need to plan the whole city in an integrated way. Integrated means we need to consider stormwater, water supply, sanitation, sewerage systems in a total, and then you can make a better decisions. Even you can plan your cities in such a way that you create a green infrastructure. They can help us in more groundwater recharge. They help us in maintaining the environment. Okay, they promote the water harvesting, promote wastewater recycling. Okay, such things can be implemented through the planning initiative as well. Okay, for demand side management, okay, that is upcoming very important focus on demand management. There are a variety of techniques are available. We can classify demand side management techniques into three categories: economic techniques, structural and operational techniques, socio-political techniques. In case of economic techniques, we can use the differential water pricing systems. Okay, like marginal cost sort of marginal pricing, where in proportion to the usage you can increase the tariff. If somebody is using more water, he or she has to pay more taxes or more tariff. So that is marginal pricing. So through economic techniques also we can implement, we can reduce the water demands. And you see your system can be sustainable. Okay, when you charge appropriate amount of tariff, people will start thinking it's saving, it's efficient use. You can promote the tax benefits, you can give the incentives and impose the penalties for offenders. Okay, so these are the few economic techniques which can be implemented to reduce the demands. Okay, structural and operational techniques like metering. Okay, retrofitting of you can say your facilities, retrofitting of your plumbing fittings. Okay, we can convert high less efficient fittings into more efficient fittings. Then controlling flows, implementing of water saving fixtures, recycling, reuse of wastewater and rainwater harvesting, leakage detection and repairs, dual supply systems. Okay, decentralized approaches, pressure reduction measures. So these are some of, you can say, measures. Okay, structural and operational measures which can be implemented suitably in different areas depending upon their local characteristics to reduce the demands of water. And so look at it. If we implement all those aspects, okay, wastewater consider resource, stormwater should be considered resource. We should follow hybrid systems. We should implement demand side management. Then we can really achieve the sustainable water management. So for sustainable water resources management, you need to integrate it. We have to use the integrated approach, that you need to integrate the different components of a hydrological cycle. Okay, rather than following individual management of individual components, we have to follow integrated water resource management of all hydrological cycle components. That is required for sustainable water management. So all components of hydrological cycles should be considered, and management decisions should be made after considering their interactions. So we should consider their interactions, all components: stormwater, wastewater, surface system, groundwater system, climate, energy uses. Okay, so all these things need to be looked into integrated way. Okay, and then only we can. So for sustainable water management, first option is we should follow integrated water resource management approach. Second thing is, water supply options need to include not only imported surface but and groundwater, but also locally collected rainwater and used wastewater, reclaimed wastewater, that has to be considered as a source. Okay, we need to manage the demands. Okay, you need to implement variety of, you can say, planning and other you can say initiatives. Okay, for to promote the rainwater, to promote wastewater recycling, green infrastructure, etc. So these are the sum of options which we need to follow for sustainable water resource management systems. Any questions, please? If anybody is having any questions, you are welcome.
Are the participants wanting to interact? Please come forward.
Okay, so what is then? So it means the solution lying, when we just from we can conclude from our discussion so far, is that present water management system is not efficient. We need to consider integrated view of all the systems. That's why for sustainable water resources, we have to consider integrated water resource management. Okay, so what do you mean by the integrated water resource management? So integrated water management can be contemplated in at least three ways. Okay, a systematic consideration of various components of water resources system, like surface, groundwater quality and quantity. So all the components need to be considered. We need to consider their interaction. Okay, interaction of water resource system with other systems, like interaction between water, land, and environment, that has to be considered, and interrelationship between the water and socio-economic development. Means your stakeholders need to be considered, their socio-economic profile, their socio-economic habits. They need to be taken care while you are devising the management strategy. So all these three aspects need to be considered. Okay, in a integrated water resource management approach. Okay, and the integrated water management can be investigated, it can be explored through system engineering techniques. Okay, through the different type of management models. Means before you can see implementing them, we can generate the water management strategies, we can investigate the different policies, and then after the you generate number of, you can say, solution options, one can take a better option. We can we can make the informed choice. Okay, so that can be done through the water resource integrated water resource management models. Okay, because before really taking decisions, you need to weigh the options, that which option is better and which option is not better. So how you will generate those scenarios, and to simulate the scenarios and water like resources systems, you need to consider models. So nowadays a lot of models are available which can be used to investigate such things. So in integrated water management thing, okay, this is the complete conceptual framework that you need to consider the whole water supply, sanitation, stormwater, coordination between the different components, legal systems, socio-economical things, environmental goals. Okay, so all things they need to be considered. So now I'm just presenting a case study, okay, where we have investigated the integrated water resource management, and we developed a system model, okay, to implement and to generate different scenarios of integrated water resource management for a typical urban area, that is Ajmer Fringe. So this is not a lone city, the surrounding areas as well. So this is a case study, and here in this particular case study, we considered the complete system, and we integrated all the systems. Like we considered multiple different type of sources, we considered their source characteristics, then different type of demands, their quantity and quality requirements, then the different type of the infrastructure requirements, and their system characteristics, and then how we can integrate them, okay, and we can generate the location options satisfying the depending on the different criteria. Different criteria are like satisfying water demands, restricting water usage, restricting imported supplies. So different policy scenarios are investigated through this integrated water resource management model. So this is the system that we have considered. Like we can from the source side, we can create multiple sources, and number of sources, and number of surface sources, and number of groundwater sources, and number of local sources, and we can put a lot of demand management options as well. Like demand management options, they are also acting just like a source. When you achieve a 10% saving in water, that is a big saving. So source side, we implemented different demand management options as well. In water demand side, domestic, industrial, other type of demand like floating population, floating water demand, fire demand, industries demand, agricultural demands, or domestic usage demands. Then all these sources and these demands, they have their own constraints. Constraint means their characteristics. Like from source side, they may have limitation of availability of a certain quantity with respect to space and time. They may be having certain quality restrictions that, okay, they may require different sort of water treatment, okay, they may require different sort of, you can say, conveyance systems. So look at it, water availability is treatment requirement, its variation with respect to space and time, then what type of treatment is required, conveyance system, kahan se means whether we are transferring water from nearby or from long distances, okay, and then their economic considerations like the infrastructure cost, their operation maintenance cost, all those cost factors were also be considered. Means socio-economic considerations were also part of their constraints. Similarly, on demand side, demand have their own, you can say, characteristics, like different users may have different demands, okay, different time period demands. Some users may be requiring different sort of quality requirements, so they have their own constraints, okay. So how these demands and their constraints, sources of their constraints, and and your overall water supply system, which involves the water distribution system, treatment plants, wastewater treatment plants, okay, pumping stations, how the system, and they have their own constraints as well. So how all these things need to be integrated in a model, and then how we can generate different, you can say, water use policies, and we can allocate that how much water should be allocated, and from which source how much water will be supplied to which type of demand. So so that overall your system should be satisfied considering a particular criteria. So that was our model, and we have developed it, and we have demonstrated its application for Ajmer city. So this is overall modeling process and components. So we use the GIS okay, to create a digital database, and then different type of surface water, groundwater, okay, because we have considered local surface sources as well, also the imported sources, surface sources, also groundwater, treated wastewater, and demand management options as well. So how with respect to space and time, the quantity of water will be available in surface local sources, means lakes, that need to be estimated with a space and time, okay, that has to we did rainfall runoff modeling to estimate the amount of water that is coming into those lakes with respect to space and time. Then what is amount of water that is available in the groundwater, how much water can be extracted from the groundwater safely. Then what are the other options from imported supplies? They are available. How much water is you can say generated wastewater, how much treatment it is required, what will be the treatment cost, and when we want to recycle it, what should the system of recycling and its cost associated with this. Then we have explored the different water management scenarios as well, like pricing, water rationing, okay, ground water harvesting. So few demand management, you can see initiatives were also integrated in this. Okay, so just look at it, and then users, we estimated demands of different users with respect to space and time. I'm using a word space with respect to space and time because your hydrological cycle is not constant with respect to space and time. When your hydrological cycle and their components are not constant, it means the availability of water is changing in the resources with respect to time and space. Okay, as बरसात अच्छी हुई, as maybe water is available, tomorrow it may not be available. Okay, so those aspects means uncertainty in the that need to be considered in. Okay, so that's why I'm saying the space and time. And so, and we have considered an objective as that satisfying the demands, water demands of all the users, how our system should be optimized. Okay, so that was our model objectives. And this is the conceptual framework that the model can consider n number of surface sources, n number of groundwater resources, and we consider individual groundwater well, tube well as just one source. Okay, so n number of groundwater tube wells are possible. Then n number of local sources, local possible sources like lakes or maybe any other type of local sources. We have considered reuse. We have considered the centralized and decentralized both systems. So treatment units, wastewater treatment, decentralized units. So multiple units are possible. So we consider them as a source. So multiple sources of wastewater and number of demand management initiatives. Okay, so this is an n-dimensional problem. So n number of surface sources can be integrated, groundwater sources, local sources, reuse, potential demand management things. They can be integrated with the system, and they have their own system characteristics and corresponding cost associated. I mean the cost that is associated to supply water to different users from a particular source, it will be different depending upon their treatment needs, depending upon their basically availability, depending upon the other energy consumption, other criteria. Then we have different, you can see users, and users have the different demands in the quantity as well as quality. So all these are integrated into a mathematical programming model, and then the system was optimized. Okay, and it generates the basic water allocations from the different sources to satisfy the different demands when your system is optimized. Okay, so this was objective function. Okay, which says that your decision variable is allocation of water from different sources in different time periods. So your time is also variable now. It means how much water will be supplied in January from X surface source X, surface source X2, how much water will be supplied from groundwater to well 1, 2, 3, how much water will be supplied from treated wastewater facilities. So all those things. So these are the decision variables. Okay, with respect to time. So I is number of Qi means the discharge that is to be supplied from the different surface sources. I is the number of sources. It can vary from a number of things, 1 to n, and this T means with respect to time, and this is the cost factor that is associated with respect to space and time. Similarly, groundwater. Okay, water supplied from the different groundwater tube wells, water supplied from the different wastewater treatment facilities, recycled water, and then basically local surface sources, demand management options. Now here we have considered the interaction as well. Interaction of surface and groundwater. Just imagine that your groundwater cost is a function of head. कितनी डेप्थ से पानी पंप कर रहे हैं. So your cost of pumping is a function of depth of water in groundwater. Okay, when you withdraw groundwater to satisfy a need, your surface system, your water level will goes down. जैसे water level कम होगा, its cost will increase. Okay, simultaneously your surface water is interacting with the groundwater through the recharge, because from the surface sources, rainfall runoff, your recharge is taking place. So your system, surface system and groundwater, both systems are in dynamic interaction. So simultaneously with respect to space and time, you need to consider their dynamic interaction as well. So a groundwater model, physically based model, was also integrated with the surface, this mathematical model, to determine the cost in each iterative run of the model, okay, at different time periods, to take care the change in groundwater status as a function of withdrawal and recharge. Okay, so that is and this is the cost function from groundwater. This is groundwater depth, this is groundwater withdrawal from the jth to well in time t, because this cost will change when you dw change. So this is a implicit function, means your depth is implicit function of the cost. And discharge है, discharge की वजह से आपका dw change हो रहा है, so it's a non-linear problem. So non-linear optimization problem. Okay, so we use a sequential linearization process to solve this particular problem and to obtain the results. And these are the constraints on imported sources, like in different time periods, what is the maximum quantity that can be available from different sources, surface sources, groundwater, local surface treated wastewater. So कितना था पानी किस time पर मिल सकता है maximum. These are the constraints, source constraints. Similarly, system capacity constraints means your infrastructure is have limited capacity. It cannot, like at a certain point of time, your demand is very high, but sometimes due to limited pumping capacity, you cannot withdraw water from the surface source. So system constraints are also considered. Okay, like system capacity constraints, treatment that includes conveyance capacities, include pumping capacities, treatment capacities. Then we also ensured a water balance, that the amount of water that is like supplied and treated wastewater, that should be balanced. Okay, your groundwater recharge and groundwater withdrawal, that should be balanced. So we have placed a water balance constraint as well. Then water requirement constraints means on the different time periods, water needs of different users that need to be satisfied. So water needs in a, from water needs from the different users, this has to be supplied from different sources, and these are the efficiencies that like distribution efficiency, treatment efficiency, all efficiencies were also considered. Then basically these are the non-zero constraints. Okay, and finally the groundwater, we have integrated the solve the surface and groundwater interaction non-linear problem through the successive linearization. And this is the time step that how groundwater was making a decision, like for each allocation, we need to calculate how much water is withdrawn from groundwater. If a certain amount of water is withdrawn from groundwater, what is the change in groundwater table status? Accordingly, your cost coefficients need to be updated. Okay, simultaneous recharge is taking place. So that iterative decision is going on unless a criteria, conversion criteria, is satisfied. Okay, so that was the model, and we have investigated. Our problem was that we need to find out the least cost integration of various sources of water in water supply system was made, and allocation of water at a minimum cost subjected to different demand and source capacity constraints. Okay, in selected planning horizon number of years. So that was the problem, and the solution of problem determines quantity of water to be used from various sources during different planning periods corresponding to minimum cost. Okay, impact of different management policies on groundwater, that how groundwater is behaving if you are implementing the different policies. Potential use of recycled wastewater, okay, how it can affect our sustainability water resource system, that was also investigated. Okay, so this is problem, like we have considered number of surface sources, like imported sources 1, groundwater, number of groundwater sources, number of local surface sources, treated wastewater. Okay, similarly demand of municipal demand, industry demand, fire demand, railways bulk demand, and floating demand. Okay, and different type of management options like rationing, water wastewater recycling for potable and non-potable both uses. So these were the some of demand management things were you can see investigated. These are the different scenarios. okay, which were conceptualized, okay, and we have investigated the outcomes. Okay, so I am showing the results of the last scenario, scenario number 7, that is integrated groundwater local surface urbanization effect and treated wastewater for non-potable applications. Okay, so these are the allocations in different months, like for year 2020 and 21, for the different months, how much water need to be imported, supplied from the different sources, and how much treated wastewater can be used for non-potable applications, okay, to make your system sustainable. Okay, so this is the scenario how how much water from which source in which month need to be tapped to satisfy the demands, and these are the groundwater cost, okay, local surface sources and groundwater use. These are the demands of different users. Okay, then these are the demands satisfied. The demands are satisfied in this particular case. If you look at the other scenarios, when we are not integrated the wastewater and demand management in some years, okay, your water system was not sustainable. Okay, so different sustainable scenarios were investigated. Just look at it. These are the scenarios that how the basically imported water, how much imported water was used, how much groundwater was used, different local sources and treated wastewater, and this is the cost in different years, and this is the total demand, total you can say supply, and the losses. These are the losses. This is demand, and this is supplied from the different sources. These are the quantities to be supplied from like imported source. So this is the last priority. Okay, this is the imported source initially. Just look at it. Unless your all the local options are exhausted, your imported supplies are less. Okay, but whenever like your groundwater, so your groundwater is this. So because it is cheap source, so due to least cost integration, okay, the complete whatever water available that was tapped first, then local surface sources. This is Khanpura, Phai Sagar, Ana Sagar. So local 3 sources were tapped second, and the next is basically your imported supplies. In the end, it has opted for the treated wastewater. So this is how least cost integration of different water bodies. We have placed a restriction on groundwater that you cannot withdraw groundwater more than recharge. So that condition we have placed while putting the environmental considerations, okay, into your water management model. Okay, so these are the total demands and supplies in different scenarios. See the different cases. Okay, case 1, 2, 3. So just look at it in case of quantities of water supplied in the different scenarios. So only sustainable cases is when treated wastewater was integrated, demand management things are implemented. Okay, so these are the demands satisfied in different case. So case 1, when the present scenario is this, that our demands are only, they're always like less than 50% level. This is the existing system, this blue line, and this is case 4, 5, 7. This is the cases when the whole demand is satisfied, and these are the scenarios where we integrated the treated wastewater into the system in addition to imported supplies. And this is the cost in different options. Okay, so challenges, issues and challenges in such a water management system. You see, when you integrate the different sources and for different demands, okay, it have their own, you can say, issues. So issues and challenges, issues are on source side, issues and challenges, okay, on demand side, issues and challenges. So these are the different things. System variables. So on the source side, just look at it. Correct representation of catchment and meteorological conditions is very critical. Means you cannot determine the correct availability of water in the different sources unless you consider correctly meteorology and catchment characteristics. So for future management, you need to estimate your surface and water availability in different sources very correctly. And to do that, you have to consider all the hydrological cycle component. You need to estimate all components with respect to space and time. You need to incorporate spatial and temporal variation of catchment characteristics and meteorological characteristics into your computations. So this is the challenge. Okay, in case of basically source side. In case of demand side, correct estimation of water demand is again a challenge with respect to space and time. Okay, and both your surface source or sources, another challenge is that your land use land cover is dynamic, your meteorology is dynamic. Climate change is happening, so you need to consider the climate change effects. Your land use land cover is changing daily, so you have to factor in that how your water resources availability will change with respect to change in land use land cover things. That has to be, this is a challenge. So another challenge is in case of the system, that your system variables and their relationships. We need to correctly define all the system variables and their relationships, interrelationships, okay, for their correct representations. Okay, so these are, of course, legal system, institutional system, strengthening of legal and institutional systems, okay, educational awareness, socioeconomic challenges. These are other type of challenges, like socioeconomic challenges. Tomorrow, to implement the wastewater recycling, you need to convince the peoples that it is safe, okay, and it can be used safely. So those things are the some of the issues and challenges. Okay, so these are that's all from my side. So if you have any questions, you are welcome.
Participants, if you have any questions, please you can unmute yourself, or you can even type in the chat box. Sir, I have a question, sir.
Yeah, please.
Sir, can this model be applied to any location?
Yeah, it can be applied to any, because that is a model is generic. Okay, simply you need to change the input parameters. That can be used for any like city or any area or catchment. But for that area or city or catchment, you need to consider appropriate like data set for that area. You need to prepare that, and that has to be supplied.
So the GIS based dataset can be used for this, right?
Yeah, it is a GIS based only. We use the GIS sections because GIS is a tool to incorporate spatial and temporal variability of catchment characteristics into your water resources estimation.
So normally there is some difference in the GIS observations and the on-site observations. So does that make a difference into the prediction sort of things?
GIS, I think GIS is a tool means that converts your real world into digital one. So whatever data that you are measuring in the field, that data is only going into GIS. So GIS as such is not collecting data, it is not capturing data. We need to supply the data to GIS to prepare its digital environment, and then we can implement the rainfall runoff modeling and the type of, you can say, estimation things.
So thank you so much, sir. If any of the participants would like to interact with sir, or if you're not having any questions right now and would like to have your questions answered in a later case, just let us know. We will share your sir's email with you, and you can contact to him directly. Thank you so much, sir, for taking out time from your busy schedule and enlightening us with such a wonderful aspect of integrated water management, which is the need of the present day, crucially.
Yeah.
Thank you, sir, on behalf of IPS Academy, Institute of Engineering Sciences, Indore. Thank you, sir.
Thank you. Thank you.
So we have a compliment from Venkat Raman, sir. He says it was a very nice presentation.
Thank you. Thank you.
So, participants, we will be meeting in 5 minutes again for the next session, which will be taken by Dr. Rajesh Ranjan, sir. He is from the University of South Bihar. So, we'll be meeting in just a few minutes. Of this AICT sponsored 1 week online short term training program on water quality complication, restoration, and environmental conservation of existing water bodies, Module 2. And we have with us today Dr. Rajesh Ranjan sir. He is an assistant professor at the Central University of South Bihar with PhD in environmental sciences from JNU. He is an expert in environmental chemistry, biogeochemistry, and aquatic geochemistry. He has been awarded Sat Paul Mittal JRF in environmental sciences from and the UGC JRF in environmental sciences, along with exchange doctoral student to Stockholm University, Sweden. He is also qualified UGC NET in environmental sciences from CSIR NET in Earth, Atmosphere, Ocean, and Planetary Sciences, and also GATE in Life Sciences. And we are really privileged and honored to have you with us today, sir, and thankful that you could take out time from a busy schedule. He is a significant researcher with numerous research articles and books like Sediment Dynamics for Changing Future, Management and Sustainable Development of Coastal Zone Environments, which is a Springer book. I am really indebted that you accepted our invitation and you could be here today with us, sir. Thank you so much, sir. And I request you to please start with the presentation now, sir.
Okay. Thank you, Dr. Devanshi. It's my honor to also accept your invitation because most of the time we faculty members generally interact with the science graduates. And but here I am interacting mostly to the engineering graduates and the teachers. So this is really also very good from my side to accepting your invitation. Uh, I am basically a environmental scientist and not like a mathematician like you people and the modeler what you have presented in the last talk. I will give you the basic ideas about how the environmentalist see the system. And most of the sometimes when we interact with the engineers, might be you will feel sometimes that you think system most of the things as a system, however environmentalist thinks any system as an ecosystem. So even for the soil, for you people, for the mostly engineering graduates, for the geotechnical engineering, it is the system, soil mechanics. But for us, soil is an ecosystem. Same happens for the river as well as for the any wetlands. At a given point of time when you have the topic is related to your water resources and the different types of water bodies and the so one water body related to the things is your wetland system, and the wetland is a very wide term generally. It is started with your simple lake or in your water body in your pond to it goes up to the very large coastal ecosystem which are started with the like your coral reef, mangroves, etc., even the large delta ecosystem also. And the wetland is one of the most productive ecosystem of the world, like your tropical rainforest. It is the some ecosystem or the wetland ecosystem is the second most productive ecosystem of the world, like your mangroves and the particularly the coral reef. And this ecosystem plays a very good role in the particularly for the water conservation as well as coastal zone managements. And in the last slide, also in the last lecture, professor was talking about the interaction between the surface water and the groundwater, how the surface water recharges the groundwater and groundwater also interact with the surface water. And according to that things, we generally propose any integrated water management like things. So just I am giving some overview about the my presentation. I will little bit talk about the what is the wetlands and the different types of wetlands and the importance of the wetlands. Some and I will again come with the some of the works which I have performed particularly in the case study type of the in the Bihar, because Bihar is divided into the two parts. One is the northern side of the river Ganges, and the one is the southern part of the river Ganga. So now here I am considering the North Bihar part is mostly the northern part of the river Ganga, because the Patna, if you go north to the Patna, then near up to the like Nepal, or like your to the in the west of Bengal, in the northern part, it will come generally the northern part of the Bihar, and the southern part of Bihar where I am staying at present, your basically Gaya district, and which is near to the close of Jharkhand, as well as other parts of the Jharkhand district borders. So if you see the basically the geological structure of the northern part of the Bihar is totally different from the southern part of the Bihar. Northern of the part of the Bihar is mostly alluvium, and the plain is made up of your Gangas, as well as the Kosi, as well as the other Gandak, which river generally emit from the Himalayan rivers. However, the southern part of the Bihar is mostly dominated by the Chota Nagpur plateau. So the if you see the structure, geological structure is totally different. So I have given the both two studies. One study is performed in the our own city in the Gaya, and however the case study number A, Kavartal Wetlands, is the basically a newly designated Ramsar site. You know, the Ramsar site is the very important site, and Ramsar was the convention performed in Iran in 1971. They designate any water body which is of the international importance. So this is the first type of wetland in the Bihar which got this designated site, Ramsar site. And after that I will show you the some of the conclusion part why this is important to conserve these things. So now coming on the definition, by definition, if you see, a wetland is defined as lands transitional between terrestrial and ecosystem. So transitional ecosystem, it means that where the aquatic ecosystems meets with the terrestrial ecosystems. Suppose that we are taking an example of pond. Pond is where the depression occurs, where the water is going to reside for a longer period of time, or for a very smaller period of time also. Uh, so and after that the terrestrial things are started. So by this the definition, if you see anywhere the ponds, lakes, estuaries, reservoirs, or even any area, yeah, even temporary or permanent, if we will go by the definition of this wetland, it says that whether the water is of the fresh type or the marine type, either is the static or flowing, or it is of the basically the temporary or permanent, it includes all, comes under the umbrella of the wetland. So wetland is a very wide definition. We generally as a people, we only consider lake as well as the many good ecosystem like your Chilka lake or the Himalayan lake, or even for the mangroves like your Sundarban Delta, or in the southern part of the India there are many wetlands are there. So some are of your important wetlands of your fresh water as well as the marine water wetlands. I started my career with the coastal ecosystem, where I have performed my PhD on the Pichavaram, the southern part of the India, where that was the marine ecosystem. When I migrated to the Bihar, there was no any marine ecosystem, except that I have to visit to the west of Bengal for the Sundarban. So here I am talking mostly about the freshwater ecosystem, freshwater system, and not the marine water system. And generally the wetlands is called as a kidney of that ecosystem. Just like in our body, the role of the kidney to purify or detoxify the system things, or filter the other harmful substance which is generally in a product of our digestive system or the other system. Just like the kidney, wetlands also purify the water, air or water, or it helps the ecosystem to perform better. So if we see by the classification of wetlands, this is your marine wetlands, inland wetlands, man-made wetlands, like that. So by definition, if you see, there are lots of things comes under the in the ambit of this wetlands system. I'm giving some of the very good picture of the wetlands, like your, I'm just giving the Kavartal wetland of the Begusrai of the Bihar, also the Nainital Lake, also a type of wetland, like your Run of Kutch is also a type of wetland. Chilka Lagoon, which is present in the Odisha, is also a type of wetland. And you see, this is the Pichavran mangroves or the Sundarban mangroves of the West Bengal. This comes also under the preview of wetlands. Kaveri estuary of Tamil Nadu is also a type of wetland. Even the backwater of Kerala also comes under the wetlands, and the Sambar Lake of Rajasthan also comes under the wetland. So if we see, the wetland is basically a very large areas covered, but as compared to the terrestrial ecosystem, wetland consists hardly the 3% of the overall area of the world, of this planet Earth, terrestrial land, 3%. But for the environmental perspective, these wetlands play a very major role in any, for the environmental conservation. That conservation either related to your air purification, or related to your water purification, or for the recharge of groundwater, or from the other perspective also. In the next slide, I am just giving the what is the total wetland category in the India in the 2014. That this paper has been taken from the Vasi et al. First time he has given the idea about the, through the remote sensing map, he has calculated the total area of the wetland in the India. So you see, the natural wetland consists around 145 area in the hectares. Man-made is related to man-made is 27.6 area in the hectare, and this is the natural. So this part is your basically the natural inland type, and the coastal also. So coastal area, the coastal wetland in the India is relatively more, or approximately 2.5 times more than the natural freshwater wetlands. If you see the importance of wetlands, these wetlands perform a very major role in the carbon sequestration. You know that we are here now, we are talking about the climate change, global warming, and the etc. So what happens that since the due to the high productivity in nature, high productivity in distance.
Yes, sir. Sorry, sir. It was some disturbance.
Okay, when we talk about the carbon sequestration, this is very important part, because most of the now the researcher is working on the climate change and the global warming, and the wetlands play an important role in the carbon sequestration, because due to the high productivity in nature, the wetland has capacity to sequestrate atmospheric carbon dioxide and deposit in the forms of your soil organic matter, or in it sequestrated in the plant itself. So, and due to its high productivity and the high biodiversity characteristics, these wetlands play an important role in the mitigating the climate change also. And even when we compare, I have already discussed that only the 3% of the world is area is covered by the wetland. However, it has stored approximately 50% of the soil organic carbon. So area wise the percentage is very less, but the quality of organic matter present in the wetland is very high. So suppose that if wetland is going to degrade, the whole carbon which is present in the soil will be go again into the atmosphere. Then see how the climate change will occur. That's why the before Ramsar Convention 1971, generally wetland was considered as a best land. Now the wetland is considered as kidney of the our ecosystem. So how the science changes within 30 or 40 years like that we are now considering wetland as an important part. You know that for the performing any of the system, one of the important is your biogeochemical cycling, and due to the high productivity in nature, and due to the strong storage of organic carbon in the wetland, these wetland acts as a not as a storage house of the many of nutrients, as well as it has capacity to store many of the pollutants also. If these pollutants will be come directly into the contact with the river water or in the groundwater, that water is not going to good for the suitable for the drinking purposes. So this wetland also act as a storage house of these different types of metals. And you know that the most of the Indian agriculture system is based on that wetland system, because particularly in the area like Bihar, or even in the most of the part of the India where the irrigation water is mostly dependent upon the surface water, not on the groundwater. Yes, now the due to the degradation of the wetlands, since water is not present in the wetland, that's why we are mostly relying in the groundwater on groundwater also. But in the previous time, mostly the agriculture, the irrigation of any agriculture field was generally taken place by the wetland system. And the basic problem with the water management system in India is the area where devoid of water, or the area where the scarcity of water, the people in that area knows how to conserve the water easily. However, the area where the water is present in a very abundant quantity, in that area water scarcity is more at present time. Because if you see in the North Bihar region, every year flood comes due to the Kosi river every year, but there are lots of problem that in that area people are facing lots of problem for the drinking purpose. However, in the Rajasthan area, naturally the area is devoid of rainwater, but the people in that area knows how to conserve water. So this is the problem. The management and the conservation strategy comes generally when you feel any scarcity. Before that, generally we never care about any things given by the nature. And you know that the biodiversity hotspots, India is a very rich in the biodiversity, because the climate of India is very good. It is present in the subtropics, and the precipitation is also high, sunlight is more. So in this scenario gives lots of permutation and combination of the natural system to evolve as a different type of new type of any species. So most of the Indian wetlands are very good for the biodiversity. And particularly I want to mention here the particularly the wetlands like mangroves and coral reefs are only present in the subtropics and the tropics. It is not present in the area like your Arctic Sea or the Baltic Sea or the temperate region. And these areas, particularly the mangroves and the coral reefs, are important in playing a role in the mitigating the climate change. Also know for the flood control, since this is the buffer zone, now that you have seen that the most of the cities in India where the flood are coming every year, this is not due to the only due to the heavy rain occurrence, but in the ancient time when the urbanization was not taken place, in that time every city has its own wetland ecosystem. So when the rainwater comes, firstly it is going to deposit into the wetlands, and after more water when it come out from the wetland, then it enter into the city. But now every city of the India where the wetland was present there, now it was filled, a new building was coming. So whatever the water precipitating easily running out from the city and causing the flood. This happens also in the some 2 or 3 years back in the Patna also in the northeast. So even Bangalore, we have sometimes the flood like scenario happens, because the totally the wetlands are going to degrade, as well as the wetlands have been now filled for the construction purpose. And if we see the example from the protection, you know that in 2004 tsunami, when the tsunami occurred, that time the area in the Tamil Nadu coast where the mangroves were present in abundant quantity, that area was very least affected by the tsunami. However, the area where the mangroves was not present totally devastated. So how these wetlands acts as a protection from the cyclones. Also, if you see the suppose Bhitarkanika mangroves, they always protect Odisha from the coastal waves. Also, the Sundarban mangroves protect Bengal from the coastal waves, and those, so that's why wetlands play an important role for the basically the in every aspects of the environment conservation. So just I am giving some of this is the recently a review article written by one of my PhD student, just some days back it was published in the village. So for the detail, if anybody wants to know about the what is the ecological and societal importance of the wetlands, he or she can go, or I directly write to me, I will send him or her to the that paper. So basically on that basis, I have prepared my slide. So see the wetland in the North Bihar. I have already discussed that the wetland is mostly present in the northern part of the Bihar, because there are many rivers, and the depression makes such in the geomorphology that the many chars, tals, mounds in the local language, and many ponds existed in that area. And the major wetlands of the North Bihar are basically the one is present in the Begusara district, which is the Kavartal. Other is in the Darbhanga district, Kusheshwar Sthan, and and the other was your Brela Lake, in the which is present in the Vaishali, Moti Jhil in the East Champaran, and the Goga Bill in the Katihar. These are the five major generally wetlands is present in the northern part of the Bihar. So all of these five basically wetlands, only the Kavar Lake is designated as Ramsar site, because this is very good place, and this Kavar Lake was considered as one of the second largest lake of the South Asia once upon the time. But now if you will see, that area is totally devastated, and if you go during the when the flood is not there, or if we go in the summer time, there are lots of mafia. They fight to each other for the grabbing of the land, because this area of the wetland land is very productive in nature. Just you plow the area and put some seeds, naturally it has capacity to grow many of the fruits and the many of the paddy cultivation or the wheat cultivation. So but now the even the government of Bihar are trying best to revive the or restore the wetlands, but might be after the Ramsar site this wetland is going to restore. The rest of the lake in the Bihar is, they are very good wetland, but they are in the not in the very good condition. So most of the wetlands in the Bihar is not in the good condition basically. And these are the major services provided by the wetlands. You see how it is helping in the groundwater recharge, heavy faunal diversity, climatic balance, fish diversity, carbon storage, etc. So this is basically the function of an wetlands. I am talking about the Kavartal area. This is the basically the area of the Kavartal, where the I have performed some work. See in the how the changes with the time. When the flood comes, whole area is generally flooded with the water, and when the flood goes, or in the summer time, it is the where the wheat is going to cultivated, and the many of the mustard and etc. Rabi fasal like that. However, in the flooding time, that this is the aquatic plant is also present, and due to the nearby area, where due to the discharge of untreated wastewaters and etc., how the water hyacinth and the other things also basically growing in that area. You know that the water hyacinth is one of the very invasive species in India, and the most of the wetland in India is basically now is going to degrade due to that water hyacinth. You see here local people or the mafia have captured the bird, because you know that these birds are generally migrated from very long distance. Even the Siberian crane also comes for the breeding purpose in the Kabartal, and the local people, not basically the local, I am talking about the local mafia, generally use this type of net and catch the birds. Even the government of Bihar has put the Department of Environment and Forest, but see the how the pathetic condition is existing in the wetland of Bihar. So I have worked how the wetland ecosystem has changed from 1990 to 2015. On the basis of the land cover and the land cover and land usage. So these all data was taken from remote sensing, and after that the application of GIS, we have calculated the areas wise. So blue color here is the basically the water. So see, if you see the from the 1990s to 2015, how the blue color means water has decreases over a period of 25 years, like that. Even this is 2021, so might be scenario has been changed, but these are only 6 year backs. So see, except open water area, everything has been increased. Agriculture area has been drastically increased from 4.88. I have taken the 20 years here, 20 years. After that, the 25 years. So see, except and the fallow land. So mostly open water, it has decreased 6.32%, 7.22%, 0.9%, like that. Agriculture area has changed drastically. So whatever the water was present, now the due to the scarcity of the water, the totally the better has changed as agriculture land. And so and even the fallow land has been also increased, means the one is the agriculture part, other is your water part, the rest of the area which is created as a fallow land. So if we see in the 25 years, the total square kilometer has changed from like your minus 4.04 to minus 6.32%, like that. So after that, I have tried to calculate how in that area, you know that in nutrients is one of the important part of any ecosystem, and particularly in the freshwater ecosystem, phosphorus plays an important role. It causes the eutrophication, means increase in the nutrients, which causes the growth of the algal mats. You will see everywhere now the wetland has been degraded, or the eutrophication is taking place in the springtime, or even in the particularly before the monsoon. You will see that there are algal mat, greenish type of things will be present in the everywhere, most of the wetlands, because phosphorus enters through the different sources, through the domestic through the domestic wastewater, or through the agricultural runoff, because we are adding diammonium phosphates from where the phosphates are coming, it causes the eutrophication. So if we see, you see the here I have calculated the correlation. Generally we try to find the correlation, that how the system is behaving and the parameters are behaving to each other. So see, the phosphate is directly correlated with agriculture area, means if agriculture area are increasing, phosphate concentration are also increasing. Same happens if the open water is directly correlated with the negative of the sulfate ions, means the mostly the sulfate ions in that ecosystems comes from the weathering of the rocks present in that area, and agriculture area is negatively correlated with the open water, means you are using agriculture on the basis of your open water, because the land has been the flooded land has been decreases and the agriculture land has been increases. So in that sense we say that the mostly the phosphorus as well as the nitrates is coming, and see how very good correlation with the phosphate and nitrates. It means that the either when we adding the urea along with DAP, means then phosphates are coming from the DAP and the nitrate is coming from the urea. So in the overall system is going into the eutrophic condition. Again, I am telling that the eutrophication is the stage where the system has lots of nutrients, and due to the lots of nutrients, the algal growth has been taking place, and due to the algae growth, what happens that the sunlight cannot penetrate inside the deeper of the any water body. Due to that, dissolved oxygen decreases and the fishes may die easily. So what happens, larger aquatic life decreases after the time, and already the algal growth taking place. So this is also happening in our area. After that, one of my student has worked on the how the because you know that the most of the time now the statistical and DIS approach is coming out any places like the simple water chemistry. So he has basically the collected tried to do the seasonal variations of the water chemistry in that area, how the impact of season is taking place. So you see the particularly in the monsoon time, the phosphate concentration has been increased drastically. This phosphate concentration in the monsoon time, and mostly these phosphates are coming from the runoff, agriculture runoff, because we are adding lots of phosphates in the system. Also, so here is the major things related to phosphate. And so what was my major finding, that the seasonal variations shows that the anions follow like the trend of sulfate is the most important, followed by the chloride, bicarbonate, nitrate and phosphate. For the surface water characteristics, nitrate and the phosphates are very important part. Generally, because nitrate and phosphates both are an important nutrients, and nitrate has capacity to move to the groundwater. However, phosphate not. Generally, nitrate is easily soluble into the water. It enters to the groundwater because nitrate has negatively charged, and the size of nitrate is very less. And in the soil, the clay repel the nitrate. So what happens? It is soluble. Clay repels the nitrate, so whatever nitrate present in the soil easily reach to the groundwater. And you know that the one of the famous disease in the baby is called your blue baby syndrome, mostly related to your nitrate contamination in the groundwater. So if any area where the nitrate is more, there is possibility that if the aquifer recharge is taking place, and particularly your unconfined aquifer, then permeability is very high to that aquifer, the nitrate may go directly to the groundwater. However, what happens for the phosphate? Even in the large quantity, phosphate generally less or least permeable to the groundwater, because due to the high size, means the greater size, cannot enter to the groundwater, and also the chelates formation takes place on the surface of the soil. So major concern here, phosphates reside in the aquatic ecosystem for a very longer period of time, and generally if we see the chemical cycling, nitrate is reside, the denitrification reaction takes place, so nitrate also goes into the atmosphere. So nitrate generally it will present in the any water, but it mobility is very high, either it goes into the atmosphere or seepage to the groundwater. But the phosphates enter to the system is reside for a very longer period of time, and it causes the eutrophication. Now in the summer, if you see the summer in time also, and even the very least quantity of the phosphates can cause eutrophication. So the concentration of phosphate in monsoon is more than summer and winter, and the high concentration of phosphates and nitrate in monsoon is due to the runoff from the agriculture area along with domestic waste from the adjoining area, which contributes both nitrate and phosphates. This is basically the major sources of the nitrate and phosphates are the domestic wastewater and the using of the phosphates and nitrates as a nutrients. So if you see the how the geochemical process, the water chemistry, the water quality in the, this is the different type plots generally we see to see the infer the what is the geochemical concepts behind the any water chemistry in any wetland ecosystem or even in the groundwater ecosystem. But using the any plot which can be used in the groundwater into the surface water is not always advisable, because the residence time of groundwater is very high as compared to the surface water. In the surface water, evaporation rate and the transport of the one system to another system means pollutants. It generally the surface water acts as an open system easily. Uh, uh, However, the groundwater up to some extent it acts as a closed system because not so much influenced by the environment as compared to the surface water. So directly sometimes why we should caution about which plot should be used for the infer the surface water quality. So here I have used this plot. So mostly the dominated by the carbonate weathering, means the water is mostly the weathering is taking place due to the carbonate weathering, because most of the calcium and nitrogen and so calcium, magnesium and the other plots, so that the carbonate weathering play an important role along with the anthropogenic addition of the nitrate as well as the phosphate. So this is the basically the geochemical plots, how the in the season wise the phosphates and the nitrate concentration has been changing. So you see the mostly this part is the mostly changing along with the northern part. So phosphate concentration is high in the northern region during monsoon and the winter, whereas during summer it is concentrated toward the southern part. What happens that the mostly the entry of the water system is taking place this northern part, and the southern part when we will go into the summertime hardly will find water. At in the patches you will get the water, but in the whole area is flooded. Even the comparing the data with the summer, monsoon and winter is very tough. You have to suppose that in the monsoon time you will get lots of water sample, but in the summer time you will get hardly 20 and 30 samples. So comparing this data and the plotting the graph and the finally the computing in the GIS system for the plotting the contour is also sometimes very tough. And many of the times reviewer asks this question, then how you are comparing this data where the sample is very less as compared to the summer and basically the monsoon and the winter time. But on the basis of that, even that is so that the northern part is very much dynamic as compared to the southern part. And the same happens for the nitrate. I have plotted many other plots, but since I have discussed that the nitrate and phosphates are an important part for the surface water bodies, all nutrients are important, but nitrate and phosphates are more important than the other nutrients. So the most significant source of nitrate in the wetlands is of the biological oxidation and the nitrogen-rich organic matters such as domestic sewage and the agriculture runoff. And the nitrate concentration is highest at the northern extreme and southern part. In that area knows very well that when the summer will come, in that area water will be accumulated and will be reside. So in that area the agriculture field is more dominated as compared to the area where the water will be going to vanish in the March or April. So in that area basically we have got the water samples and calculated the nitrate concentration. So I have also calculated the what is the metal concentration in that area. You know that the domestic and the wastewater and the agriculture runoff also contributes lots of trace metals or heavy metals to the water body. So in that area, particularly the area is considerably contaminated with the lead and the cobalt. This is the and for the iron and manganese copper the concentration is less. So even that area, not only the nutrients, but along with nutrients, the metal is also present in a very large quantity. Here I have one is the called your contamination factor, where the we calculate contamination factor with the background concentration, and generally we say that the background concentration sometimes be taken from the previous literatures, or the from the earth crust value, or sometimes what we do that we take the samples from the 10 or 5 feet or 6 feet below the that the soil, so that we find the what was the basically the background concentration, considering that there is no pollution impacted that with that the depth. So on the basis of that, in that area is highly contaminated with cadmium, lead and the cobalt. Even you see that there are other parameters also. We show that you see the long tower where the cadmium is very much enriched. Apart from cadmium, you see the greenish. This is basically the nickel play an important role, and lead is also present, and mostly that area is contaminated with the agriculture runoff. Even this is my basically the last year paper. This is in the trace metal contamination in the core sediment, because whatever I have shown in the earlier slide was it was the surface sediment, but whether the in the depth of the core, whether the sediment was contaminated or not. So the average concentration of trace metals in the sediments is basically the followed is the trend, like your manganese is the present in the large quantity. Yes, even the manganese is present in the larger quantities in the natural system also. But the lead is generally considered as a pollutant, and the zinc also. So manganese is the larger quantity and the copper is in the least quantity, and it is shown that in the surface of the basically say each core contains large quantity, however deeper in the less. If we consider how the system is be changing, so basically what I want to show in the whole graph that note agriculture is contributing nutrients as well as the heavy metals. So sediment sample is in the all core shows minor to moderate enrichment to the copper, nickel and zinc, whereas in the particularly one core zinc shows the moderate enrichment, and the lead shows severe enrichment in the all core sediments. Means the lead contamination is very high in that area, and not only that, the lead shows it goes into the class 3, which is very moderated to very strong contamination. Now question arises that from where this core lead has been coming out. Even the pollution load index shows that pollution load index basically we calculate on the basis of all the cumulative effect like that. So for the pollution, except lead and nickel, the area all basically contamination is present in a very least quantity, but the lead and nickel are present in a very high quantity, and these lead and nickel generally is a part of your fertilizers, because lead is also present in the fertilizers, nickel is also present in the fertilizers. So when we consider all the parameters like your nutrients, lead, nickel, even last time some 1 month back, because the CP Bihar State Pollution Control Board chairman has called me that because you know that area is now the Ramsar site, so any things which goes against the ecosystem will be easily taken cognizance by the ministry. So a State Pollution Control Board chairman asked me, have you, because in this paper I have written that there is possibility that the Brownie thermal power plant refinery is 20 kilometers from that wetland. So there is possibility that the aerial transport of some metals might be have deposited in an area. Then he asked me, do you think that the Brownie refinery is acting as a source for the contamination in that area? Because the environmental impact assessment given by that Brownie refinery where the director or the environmental officer never given any idea about the flue water characteristics, flue air characteristics. So, and the many of the studies suggest that the around the nearby the refinery, the soil is contaminated with the many of the heavy metals or the trace metals. So as a scientist, I assume that it might be transported from there also. So it is better to ask question from me. It is better to ask Brownie refinery to first give the what is the flue gas characteristics, or what is emitting in the atmosphere, or might be some of the particulates matter, because lead, nickel and the most of the trace metals also deposited from the atmospheric deposition also. So there is also chances, but then he satisfied and asked the Brownie refinery to provide that data also. So if we see how agriculture runoff and the trace metal contamination, this is a very good correlation with the lead, with the nickel, lead with the available phosphorus. So lead and phosphorus both are coming from a common source. It means that there is chance that no lead is also coming from the fertilizers, and generally the total organic carbon. Total organic carbon is generally present in any ecosystem, is mostly the organic carbon through the process of mineralization and through the process of sequestration, natural sequestration. So nickel is showing the negative correlation. It means that if this is TOC is natural, nickel must be of the anthropogenic in nature, because this is the negatively correlated. However, available phosphorus, lead is positively correlated to each other. Same happens for the lead. Lead is also negative correlation with TOC, total organic carbon. So there is chances that the lead, nickel, both are coming from the not coming from the anthropogenic sources. Also, the total organic carbon is negatively correlated with the available phosphorus. Means this available phosphorus is mostly came from anthropogenic in origin. It means that it comes from the fertilizers. So basically, how an ecosystem through the agriculture thinks this wetland is going to be contaminated. So these are some of our finding. Wait 1 minute. So major finding was basically the significant amount of wetlands was converted to agriculture land, which shows the increase in the agriculture area from the 1990s to 2015. It was observed that a steady site is proceeding to eutrophic condition, and eutrophication is due to the high concentration of phosphorus that is reported in the study, and the average concentration of trace metals follow the order like that. So these are some of the results which I have performed with my students in the northern part of the Bihar. Now coming on the since in the southern part of the Bihar there is hardly wetlands are present, and you know that the Gaya is a famous place for the Pitarpach Mela. Everybody knows that many of the person comes to come in the Pinddan to perform the Pinddan. So what happens, and there are the 5 ponds which is present in the Gaya. They are generally used for the religious purposes. Also during the Bodh Gaya, one of the hardly 15 kilometers from the Gaya, tourist spots for the Buddhists. They are most of the country both the person who basically follow the religious or the Buddhism comes to the Gaya. So basically in the city I have selected all 5 ponds which is used to see what is happening in that ponds, because this is also a wetland. Although this wetland is a smaller wetlands, but they have capacity to recharge the groundwater. So what happens, this is area is, if you see, this is very small, the slide is not very much visible, but you see the most of the sources of that wetland is the rainwater and the local sewage line coming to the wetlands in the most of the places. Some like your one is your Bisar Talab, Dighi Pond, Ramsagar Talab, Surj Kund, Baitarni Pond. These all ponds, 5 ponds are generally when the ritual during the Pinddan, people take bath, or basically the most of the generally the panda perform religious things in near to the bank of that pond, or within they throw whatever you can see in the wetlands of the Gaya. So you see, in that area also, even in the small pond is contaminated with your chromium, zinc, and the cobalt. All ponds except your like your see with the even the Baitarni pond is also contaminated with the these 5 metals. So although this data is based on the hardly on the 6 or 7 samples in the each pond, but for the smaller pond 6 or 7 samples can be give you the idea that what is the status of that wetland. So the high concentration of trace metals have mostly resulted from the increased influx of the sewage, inorganic and organic waste derived from the adjoining area, particularly in the monsoon, and it is going to deposited in the that wetlands. So, and however metals might also have leached from the geological settings underneath or from the seasonal effects of weathering. All we know that the Gaya is the lithology and the geomorphological features of the Gaya district is different from the northern part of the Bihar. Mostly the in the Gaya, the hard rock terrain and the weathering process has lots of minerals which can contribute metals also. But I cannot just say that the anthropogenic activities play an important role. Along with that, some natural possibilities also which can going to add metals, particularly in the Gaya pond, because in the alluvium plain metal concentration is less as compared to the hard rock terrain of the Gaya, because I have already told that the Gaya is a part of your Chota Nagpur plateau. So you will find lots of small hills near to the Gaya. So through the weathering it can be added to the metals to the pond. So this is basically the water. For the even I have calculated metals in the sediment. You know that the whatever in the aquatic ecosystem, firstly it is going to present in the water, after some times it is going to present in the sediment, after some time again sediment is going to give metals to the water, like that. So there are always interaction between the sediment and the water takes place. So if there is possibility that the metal present in the water is high, there is possibility that metal present in the sediment will be also high, but this is not always true. Might there is possibility that some of the metals is easily precipitated, but some metals has capacity to lives in the dissolved form also. So but so if we see the same lead, manganese, cobalt and the copper, and this is the pollution load index, because these are 3.2, 3.1, these are more than the unity, means more than 1. So overall ponds are also contaminated with the metals. So the mean contamination factor for cobalt was very high, whereas the metals like manganese, lead and copper is ranged from low to moderate level of contamination. And generally the cobalt shows more than 5, means the in the Gaya region that pond has mostly contaminated with cobalt also. And the lead also pose a great threat to the soil environment and biota, where the mean value is around 5.25. So see, even a smaller pond, a smaller type of ponds which is present in a city is also contaminated with the your heavy metals. And suppose that wetlands is going to recharge the groundwater, then the all metals will be go to the groundwater, and generally we can going to drink that water also. So firstly we have to also see that what is the basically the condition should prevail in the wetland, so that it cannot going recharge groundwater with so much amount that this wetland is going to affect the groundwater scenario. Because you know that if wetland is contaminated, it can easily going to reclaim it, or it can be easily basically restored. But once groundwater is contaminated, it is very hard to basically restore the groundwater, because you know that it is present within the underground rock, or it might be that if the confined aquifer or unconfined aquifer. So first, being an environmentalist, try to preserve the surface water body, because the restoration of surface water body is always easy as compared to the groundwater. And so basically my conclusion is that anthropogenic mixing of wastewater from domestic sewage channels and urban rainwater runoff flowing into the water bodies alter the geochemical characters of wetland water to a great extent. So even in the both area, northern part of the Bihar or the southern part of the Bihar, mostly the urban laden rainwater are like your city water through the surface runoff. You know that there are lots of vehicles are coming inside the city, and through surface runoff, these metals goes into the pond water and deposited into the sediment. Along with that, agriculture areas and villages around the wetlands also contribute to the nutrients enrichment in the wetlands, which causes the eutrophication. Sediments get contaminated mostly due to the anthropogenic activities like your agriculture waste, application of fertilizers, animal manures, sewage, sludge, etc. These all causes the surface water contamination, nutrients as well as the metal contamination. And since wetlands sediment acts as a significant source of diverse group of pollutants, and it can be transferred to aquatic organisms through the bioaccumulation. So if any metals which is present in the sediment, it will reside in that wetland for a very longer period of time. So if water will become, there is chances that the seasonal variations of water chemical characteristics will take place, but sediment characteristic changes with season is slightly less as compared to the surface water. So once metal is contaminated, deposited in the sediments, there is possibility that through the bioaccumulation point of view, the phytoplanktons will uptake that metal. After through the phytoplankton, through the the algae will capture that metals. After that, the phytoplanktons, and through the phytoplanktons it will come to the zooplankton, a smaller fish, and finally come to us. And there is possibility that the most of the wetlands in the India is also polluted with the trace metals, and the fish edge cultivation is taking place. Then we can think that where we are going basically. So for preserving all these things, uh, my just for the humble request to everybody to, before conservation to the groundwater system, first we try to conserve or restore a simple wetlands present in your area, because the conserving of that wetland is easy task. And you know that in the Bihar, that the most of the places now the groundwater table is drastically going down, because there is due to the many things. Earlier the area which is supported by the one type of crop, now through the application of groundwater we are doing agriculture or cultivation of those type of basically the things which is not climatically suitable. Suppose that if a person who is live in the Punjab or live in the Haryana or in that part, naturally that area is suitable for the wheat production. But if suppose that we are doing cultivation of paddy, obviously you have to mostly rely on the groundwater. Same happens in the Bihar also. That's why we are using large amount of groundwater. So groundwater is going down, and the surface water recharge wetlands are is degraded and diminished. So one hand the recharge is less, other is groundwater extraction is more. That's why now the Bihar government has started 2 or 3 years back that Jal Jeevan Haryali program, that a restoration of and the rejuvenation of all wetlands which was present earlier in the even in the small villages. So for that I am just concluding my slide here. And these are some of the references which on the basis of that I have prepared the slide. The acknowledgements also goes to the uh, because these all works are performed with my own project when I got the ACRB, the Young Scientist project. And when I joined this university, then I have also got the UGC startup grant. And also my acknowledgements to the principal chief conservator of forest, because the area is mostly restricted, only the researcher can enter, because these are the bird sanctuary also, so you cannot go directly to for the sampling purposes. And mostly the work has been performed at my own university and my alma mater, School of Environmental Sciences. And these are all the three students. Deepak Gupta is now, sorry, this the Himanshu Kaushik is now doing PhD in the IIT Indore, and the Deepak Gupta is in the Banaras Hindu University PhD, and she is my Albia is my own PhD student. So thank you for listening me, and if any query, just mail me at rajeshkiranjan@gmail.com. Thank you, madam.
Thank you so much, sir, for a lovely and enlightening talk on the wetlands of Bihar. So I would request the participants to come forward and ask any questions to sir. You can raise your hand, you can type in the chat box, or you can also unmute yourself. So that was very nice listening to the work which you have been carried out, and it was very inspirational for all the activities which you are doing towards the conservation and preservation of these wetlands, which are very crucial for sustaining the life supporting systems. I thank you, sir, on behalf of IPS Academy Institute of Engineering and Sciences Indore, because as of now I cannot see any questions raised on. And if any of the participants still have any questions in later case, we shall forward it to you. And I am sure that you will be glad to solve the queries.
Yeah. Okay, ma'am.
Thank you so
Thank
much.
you.
Thank you so much, sir, for taking out time from a busy schedule.
Thank you. Thank you.
So, very good afternoon.
Good afternoon, ma'am. Ma'am, shall I introduce and then we may start, ma'am?
Absolutely.
A very good afternoon and welcome back to the AICT sponsored 1 week online short term training program on water quality complication, restoration, and environmental conservation of existing water bodies, Module 2. So, we are on the day 4 and third session, which will be taken by Dr. Anshul Pranay Gujarathi, ma'am. She is the director of Eco Solutions Pune with 21 plus, that's more than 21 years of professional expertise in architecture with focus on green architecture and sustainability. She is a lead US GBC accredited professional, IGBC fellow, and Griha trainer and evaluator. She is a PhD in green buildings, and the firm, which is Eco Solutions, is proudly engaged with sustainability mission, and it has worked on more than 340 green projects which have been credited to the company. And Anshul ma'am, along with Eco Solutions, have accomplished more than 28 awards, which vary at the various levels of local and international and national levels. So we are really proud and honored to have you with us today, ma'am. And on behalf of IPS Academy, Civil Engineering Department, I would like to thank you for taking out time from a busy schedule and enlightening us over the major issues of these green buildings. Thank you so much, ma'am. And I request you to please take the presentation, ma'am.
Thank you so much, team. I think this is the pleasure on my side totally because I got this opportunity out of my regular practical schedule to get back to some theory part. And the good part here is I am going to share few of my live projects, and I would really, be happy if you guys comment, ask questions about it. So I think this is an opportunity to have a tie between theory and practical sense, and let's see what best can come out of it. So thank you so much, Dr. Devanshi. And I think there is some error with my laptop's camera, so I would just put it off while I'm sharing because I'll be looking at two other places otherwise.
Yeah.
Thank you so much. And we will again switch the camera on after some time. That's not a problem. Thank
Sure,
you.
ma'am. Ma'am, the privilege is all ours by your presence.
So I am going to present on a topic definitely related to water, as we are already talking of water quality in terms of complications, restorations, environmental conservations, and existing water bodies. So when this topic was shared with me, I thought why not take up a slight variation in the same topic because we all are aware of how water is important to us, how water has been behaving with us, and how we have been behaving with water. There is one major aspect that remains lacking in many of the places, many of the souls, I would say, as an independent human beings, that we have stopped or we are ignorant about respecting water. When I talk about respecting water, what I exactly mean is we need to understand how water is important to us. We also need to understand very, very starkly that if water is not there with us, we are not there anymore. We all are aware of the facts, but we are also confident about our own capacities as human beings that we will definitely find a solution. You know, how to tackle this situation again and come out of it and remain under the category of very, very strong word sustainability. We will be sustainable, we will survive, we will continue living with the revised norms of water. So, friends, we all are aware how the scenario has been changing. Previously, talking India wide, we have seen rivers flowing all around us, and the kind of width we realized with that particular river, the kind of water we used to see in those rivers. Today, if we go back to the river, there is some change definitely. Probably today we see more dams coming up. The rivers that were wide enough to eat anything that used to come along their way today are small canal-like structures. Here in Pune, I am connected with all of you from Pune. Here in Pune, it's a sad sight sometimes to see the river, which was once drowning all the pools that were pass-bys and driveways. They used to get drowned in the river. Today, like river is nowhere even touching them. So because of the canals that are built, because of the dams and many other aspects. So friends, it is very, very important to understand how water has been evolving with us. And today I just thought of touching the same topic with the concept of measuring water, quantifying water. So, along with the presentation, Dr. Devanshi, I would request the team, if you have any questions, please keep, typing the questions along in the chat box. We are connected for a long time today, 1.5 hours or so. So, we have to make this session interesting because again, you guys have confidently given me a post lunch session that and the challenge is with me to keep people alive here and not dozing off. So definitely we will make it interactive, and whatever you feel about my presentation, do feel free to write in the chat boxes. So friends, going further, So three pillars of sustainability we are very much aware of. Environmental, social, economic. We do talk of all these sustainability pillars. And when we talk of environment, somehow water has been a very major element. When we talk of social aspects, we have water bodies all around us, and again, water has been connected to us in the social aspect as well, because many gathering places, many temples, and many areas, even in today's modern societies or rural areas, water bodies have been maintaining their own place. Coming to the third and important part of economy, today we are in a situation where we are purchasing water. Purchasing water, we are paying a price for it. And this price has been increasing day by day. I'm sure in this entire session of 2 3 days training, you guys have already, understood how water is scarce, how it is important, what are the percentages, how it is getting dilapidated, and many other things. I'm not repeating any of it. But on the contrary, water has been an element which is supporting environmental, social, and economic aspects. And if we want to be sustainable, we have to be sustainable with our water. Um, Now, going further, when we talk of green buildings, sustainability, and other water aspects, the aim always remains in sustainable architecture to maintain a balance between these three aspects of social, economical, and environmental, and trying to minimize the impact on the environment along with the built environment. So energy efficiency and water savings, these two are the most important goals. And if a building is supporting these two goals for a life cycle or a lifetime, definitely we can rate the building to be sustainable. Now friends, in this slide we can see the five elements of nature which are very well connected to our structures, buildings, projects, or any other aspect in our lives. So the first one being sustainable site design or land related aspects. So friends, I will go one by one. In land, in site, do we have the use of water? Indeed, yes, definitely. Through plants, we water them. We have pools, we have water bodies, and multiple things on land as well, which is related to water. Secondly, the entire topic of water conservation and quality. This is a separate element and deserves a deep concentrated effort, because in any project, any building, if water is not present, the building will not run. The third element of fire, energy, environment, all these aspects will also deal with some element of water, because in worst case, if any of the disaster comes up, we need water to take care of it. Again, coming to the energy and environment part of it, along with the energy calculations, we have pumps and motors running in for our day-to-day services, wherein energy is also counted for them. And thus, we have energy as well associated with water. Coming to the next part of conservation of resources, space, and maybe we can call it as materials. Now, when we talk about material, we have plumbing as a major element in our building structure. We have water tanks, we have rainwater harvesting, many other things that we will be seeing. So we need proper materials, we need proper space allocated for them. So water also gets its own importance in this aspect. And the last part, which is environmental quality indoors. So friends, giving a quick example, if somebody is staying in Mumbai, so that person will face some kind of humidity in atmosphere, moisture content. Moisture is nothing else but an element of water. While if the same person is coming to Pune, there will be much less moisture in the air, and thus what is getting affected is nothing else but your own human comfort. You start sweating when you have higher moisture, and you feel more comfortable with right amount of moisture. So looking at that, friends, all these five elements in nature, they are associated with each other. The way I connected water to all these elements, we can definitely connect each and every element to all of them. So none of these elements can be handled independently. They are interconnected. So there is a concept called entity relationship. All those who are already in research will know this concept. When we call of entity relationship, here one-to-one relationship and one-to-all relationship exists when we see this diagram. So similarly, talking of water today, I will definitely highlight that if anything goes wrong with water in any of these elements, your entire project will collapse. So friends, it is important to have an integrated effort, have a proper monitored observation for each and every aspect mentioned here. Going further, my friends, when we actually look at water entities in building, the water exists in the building as absolutely water, in the liquid form in its original physical and chemical state. How it is circulated in the project depends on the water supply system, how it is designed, and definitely we can relate to all these diagrams mentioned here, wherein we are using the water and also treating them. I'm sure the treatment also has been highlighted in the training session. So I am not talking of the treatment here, but using of water and treating them. Of course, after treating, we are reusing the water to a certain extent. And there is a one-to-one relationship between both these aspects. The percentages differ, the amounts definitely will differ, but it will all depend on one major aspect, that is reuse. Okay, first we will go with reduce. Reduce the use, then try and recycle it, then reuse. We also have refresh. We add more fresh water to it. We refurbish. We recharge. And we keep reminding, close the taps, close the taps. So all these awareness essentials also go along. And this is for one major aspect, that is respect. So all these elements go side by side in water entities for any building. Going to the next slide, my dear friends, this is a water balance chart, which is a generic one. Definitely you guys, everybody is aware of how this works and how fresh water, treated water, its all uses are defined along with the quantities and the percentages we are dealing with. We have makeup water sometimes, depending on the typology of the project, we have industrial process use for water, or if we don't have one source as an enough one, we have additional source, we have water tankers, or we define the use of this water balance for our independent project. Now, when we talk of the latest entities again in the buildings related to this water balance chart, we can see a few pictures here where rainwater harvesting, solar hot water system, overall water supply system in the building, STPs, pools, landscapes, fountains. There are many other things which are existing there. With Prime Minister's new, I won't say new, but Prime Minister's vision of achieving net zero by 2070, he has definitely highlighted energy. But when we talk of net zero aspects in a building, in a project, net zero waste, net zero energy, and most importantly, net zero water will come into picture. So I just thought I would highlight net zero water here Because in the same water balance chart, when we are talking of going one step beyond that, we will try and accommodate all water from our own site. We will try and capture entire resource that is coming to us in the form of rainwater or maybe reclaimed water or some recycled water. We will try not to give away a single drop of water outside our building. We will try and reduce the use of our water to the optimum so that we do not end up wasting anything when we are comparatively justifying all these concepts. My friends, we are trying and achieving a concept of net zero. The good and the happy part here is achieving zero water is comparatively easy because net zero energy is a task and we cannot compromise with power every now and then. There are multiple elements where we cannot again compromise with the power, voltage, calorific value, and multiple things. When it comes to water, we have that flexibility, we have the resources, we have the technologies already established, wherein we can target net zero on an easier front with water and waste, both elements. But talking of water, here definitely we need to identify the source, take in the water and try and accommodate the entire water in our own cycle. So coming to net zero water implementation, how do we do it exactly? We just have to add a few steps to our routine. So connect and coordinate, identifying opportunities. We need to focus on water related system with synergy. Nextly, improve your infrastructure and develop your master plans in such a way that you are not treating one element separately, but integrating all these five elements together and performing the water-based analysis on the whole on a consolidated level. Now, when we are designing the things, we can choose to design various levels wherein we are trying and using the alternative water systems. When we are trying and exploring the alternative systems, we are definitely cutting on our base water requirement. So friends, with this, we can actually define the treating of wastewater also on separate fronts, like we can disintegrate the STP for grey water and black water, treat grey water with possible root zone systems and other methods which are existing in nature, and use this water for the apt application and use. So if we are defining these strategies very, very properly, we do not face the issues of wastage of water at any area. I will be asking all of you one question which I have been facing and I have not received answers for that. So I'll come to it at the end of your end of the session during question and answers, and the question from my side will be displayed then. So when I talk of construction, when I talk of operation, there are multiple areas that we need to assess and optimize with maintenance also. So friends, if few areas for water implementation are taken care of, we can definitely look at net zero water also. How do you arrive at that my project is a net zero? You need to quantify it, you need to measure it. So friends, when we talk of measuring the water, how do we measure it is at two ways. First, when water is at rest, it is measured. And secondly, when water is in motion, it is measured. So water at rest is measured in units of volume. We all are aware of this. And this is no rocket science, but when water is at rest, ponds, lakes, reservoirs, and multiple areas can be measured in terms of volume. Now gallons, cubic feet, acreage, acre foot, whatever units you want, liters, and you can define it. Secondly, when water is in motion, it is always the unit of volume for a convenient time unit. So when water is in motion, the aspect of time will also come into picture. It is important that the difference between a unit of volume and unit of flow is considered together. So suppose we are talking of a moving river, a flowing tap, or any damn thing, we definitely will measure it in cubic feet per second, gallons per minute. So we have the time definition that gets associated with it. I hope I am quite clear on this front, and this is, as I mentioned, no rocket science, very, very clear logical phenomena. Talking of a typical building, schematic water supply in a building, we all are aware how the water is being supplied to our place. We have certain tank, we have underground tank, overhead tank, and the supply goes on. And another important part we have in water supply system is the material which is associated with the system. That includes your pipes, your suction pipe, your pumps, your service elements. So when we are talking of measuring water, we have to consider the main fixture and the service fixture as well. You cannot consider only the direct things, but we have to see the indirect things as well. On a site to make it net zero, or maybe just to make it perform the best, it is important that we understand one very, very important aspect of indirect unit, which is the water table. We have to understand that water table has impacts on our project. Water table will further define if the project can go net zero, it can achieve good savings, or it will be just meeting the mandatory norms of the defined area, or maybe it will create havoc in the project. So water table study also makes a very, very strong application in the project. Now, what is water table? If we see, it is the boundary between unsaturated zone and saturated zone in the underground for a water. We are talking of aquifers here definitely. And how does water table remain? It is the fills, that any space between sediment and rocks, it is filled with this water. And if the water table is high, it will ooze out when you dig the ground. If it is low, you keep on digging, you will never find water. So water table ideally will vary in different areas because of multiple aspects related to climate, related to topography, and many other things. Now, this groundwater table plays an important role in building foundation stability and comfort because uh, ideally the rainwater harvesting aspect, if you see, okay. Is the screen visible?
Yes, ma'am.
Yes, ma'am. Yeah. So I think just a second. I think there's some. Yeah. No problem. So it plays a very important role in a building because okay, I was talking of the rainwater harvesting aspect with regards to water table. If the water table is high, no matter what norms lie in the region, you won't be able to harvest water. And that is why the new infrastructure of storage tank will come into picture, which will again be affecting your services in the buildings and many other aspects. Not only that, this water table ideally will be dependent on the soil conditions and even the drainage in the city and how effectively the soil will drain water, and that should not create issues. We also have related river beds, related water bodies in the city area that will define this water table. So going further, my dear friends, we assume that if this water table is stable, water table is good enough for any project, not to create havoc. It will absorb good amount of rainwater. It will deliver when you need water as a secondary source. So if these things are stable, we can go further with the measurement of water. Now, measurable equipments, when we talk of water supply and distribution, as we mentioned, the first and the foremost thing will come into picture is the plumbing fixture. Now, this is any device which is connected to the system and it is interacting with water. Now, if we see these few photographs coming up, water taps, borewell pits, shower heads, tanks, water closets, multiple things related to your glamour rooms, which is nothing else but toilets, and the entire plumbing network will also be a part of this fixture system. Now, when we talk of the service entities, the fixtures that will help the water flow in the system as per our requirement. So these are also the equipment which needs measurements. So this, when we talk of the plumbing fixtures, they become the direct measuring equipment in the system, and the service fixtures become the indirect measuring systems in the measuring things in the system. Now friends, we talk of pumps and motors. How are they related? So pumps and motors support the pumping system of water from one place to another. And that is where they are actually taking in the energy which is associated. Now this energy also is converted to money at the later form, and the water is also converted to money, and that is how they are brought on the same lines. We will definitely see how that happens. So friends, here talking of motors, pumps, hydraulic systems as well. We are talking of some sensors, regulating valves, multiple areas are there. So how do we actually measure water? So there are four primary types of water flow meters. Now water flow meter will ideally take care of the water which is in the flowing condition, and the capacity or the volume of the reservoir or tank or any other element where water is stagnant will define the measurement of that particular thing. Now when water is in flow, it can be measured with four types of water meters. Now mechanical water flow meters are one of the main water meters which are in use in our domestic day-to-day lives. One of the digital water meter which is being displayed in this picture can be seen here. Then we have vortex, volumetric flow, ultrasonic and magnetic flow meters as well. Now, depends on the typology and the need of this measurement. That will define what type of meter to place where. These meters ideally range from I think 1000 rupees to that can go to around lakh of rupees as well. Again, depending on where you want to use it. So I was just trying to get a few pictures of water meters. So I searched the net and I realized there are plenty of water meters available. You can decide what types, how you want to do it, and many sources. So water meters are no more a challenge here. We can do it absolutely with ease, and by default every project has a corporation or a gram panchayat or whatever the local authority is, their meter has been there always. So why do we need additional meters? Now, going back to the water balance chart, when we realized that we have to measure water for different elements, we need to understand how much water we are, taking from bore, how much we are actually taking from the recycled area, And then when we start putting numbers in water balance chart, we should aim to achieve a practical balance. If this balance is achieved and there is no residue left out, then we can definitely mention that our project is heading towards a net zero water project. Okay, so going next about water in green buildings. When we talk of water in green buildings or any project, my dear friends, we have to talk of savings. Because अगर मैं आप लोगों को पूछूं कि आप कितना पानी रोज यूज करते हो, so people will come up with simple answers. Okay, is it okay, Dr. Devanshi, if we ask people to type their answers?
Sure, ma'am.
So, friends, can you just give me this answer? How much water do you use daily? Can you write in the chat box?
Participants, please write your answer in the chat box.
I think they're already post lunch, they're doing the meditation for post lunch, right?
Ma'am, we have two responses. One, someone has mentioned 110 liters,
Yes.
and somebody else has also mentioned 150 liters.
Okay. So where do you get these numbers from? So 125 liter per person per day is a norm that has been, as a thumb rule people are using. Somebody says through IPA this has been the study and we have 100 liters of water being used in rural areas, 150 in urban areas, or whatever the thing may be. So you have certain baseline, certain assumptions, certain number coming up. But people will definitely not come up saying we are using 500 liters per head per day. They will not say that. Or people cannot even say that I am using 5 liters per day. Because we have certain norms coming up. But these numbers again will vary. So what is required here is to arrive at a proper number. So when we talk of a house living wherein 5 people are living, it becomes very easy for us to understand and measure their part of water. So when 5 people are living in the house and we say, okay, your total water consumption as per the water meter in one day is say 1000 liters. So how can we define ki which person is using how much water? What we do is we just divide that by 5. And then we say, oh, it's on a very higher side. You are using double the water that you should have used. Then in 2 months, these people do some, effective measures. They put low flow fixtures in their house. Then they start using the water consciously. They put off the tap when it is not required. The kids say that, okay, we will not be using tub for bath. Okay, so multiple measures are taking place. And the flow meter shows 500 liters per day. So again, we end up dividing this 500 by 5 people. So 100 liters per day. We are like, okay, great. You are saving absolutely well. And we can say per person, approximate saving has risen to 50%. So on what basis we did this comparison? We took their original number and we took their revised number. Now, if I say your first number was 500 and I want you to reduce, and these people land up to, they stretch. They were ideally using low flow fixtures. They are still, using water consciously. Now they say, okay, I was taking bath for, keeping the shower on for 1 minute. Now I'll keep it on for 45 seconds. The house lady says, okay, I was actually throwing away the RO water. Now I'll save the RO water, try washing my utensils out of it, and they further make efforts. And out of 500 as the base number, this time after further measures, their water meter shows say 350 liters per day. And then we again divide this 350 by 5, we come to a conclusion, and now they're again saving. So previously that was 500, but now we can see a major makeshift in the entire process, how these people are using their waters. Now, when we talk of green building and water in green building, the certification authorities have defined certain baselines. So we need a baseline, but if a project is a new project, you don't have anything working, so you don't use water the way you want and then reduce it, but we have certain baselines which are defined. Now, all these certification authorities will define their baselines on the basis of national existing norms. They will not come up with something very new and very challenging. They cannot do it. So they will be following certain norms, certain thumb rules, and when they define their own baselines, they further define how to apply these particular baseline in terms of various fixtures. So wherever we have active plumbing fixtures, the flow rate and the pressure for these fixtures are defined. I'm going a bit slow so that I don't want anybody to miss out on these things. IGBC is Indian Green Building Council, one of the rating authorities which is dealing in almost all typologies of structures, buildings, even cities, villages are included here with, and they have been defining water norms, water baseline norms for independent typology with research and consideration. So we cannot say that it is all vague and it doesn't work, but definitely yes. So we will also see how these calculations go ahead. Coming to the next rating authority, that is US Green Building Council, that is USGBC. Now USGBC also works on a principle wherein we hear lead rating system, right? So LEED also defines some baselines for water savings. We will also see their calculator. We have GRIHA, that is Green Rating for Integrated Habitat Assessment. Even they have defined certain way and norms to calculate water. Any other certification program or any water-based specific program you look at, they all have defined some baselines. So when we talk of measuring water, saving water, we are looking at every aspect wherein water directly and indirectly is associated. The picture which is screening here is the green buildings economy, and which highlights the overall status of green buildings, benefits, and multiple other areas on a generic level, which is not only by GRIHA or IGBC, but also talks of the green building challenges and the aspirations, like by 2020, 16 billion square feet should be the built up area which is going to be under green final certification, the certified area. And along with that, what should be the least energy and water saving that is anticipated. So all these efforts, first and foremost, are going towards reduce your water consumption. Okay. So when we talk of IGBC, it will focus on low flow fixtures. It will focus on rainwater harvesting, your calculations, the rainwater which is falling in your particular climate zone. Okay. Treatment of grey water. This can differ black water, even ETPs in terms of industries and factories or manufacturing plants. So treatment of grey water, black water and processed water. Then use of captured or treated water. irrigation system when it comes to landscape, use of native and adaptive species so the landscape doesn't end up using too much of water, reducing the turf area, and trying to imbibe the plants with good evapotranspiration rate so that it is a benefit to the entire project in terms of not only water saving but in terms of overall ecological support as well. Ecological support, I definitely mean the flora and fauna as well. So this particular thing that has come up are the credit areas wherein IGBC intervenes, that is rainwater harvesting, plumbing fixtures, landscape design, irrigation system, and wastewater treatment and reuse and water metering. If you see, rainwater harvesting and plumbing fixtures are repeated here as credits because they are the voluntary points. We are talking of rainwater against required, which is a mandatory point. Secondly, we are talking of water efficient plumbing fixtures, which is again a mandatory point. So if your project is getting certified, you don't have an option, but you have to do rainwater harvesting for at least 25% of the volume. Secondly, you have to achieve a minimum percentage defined with plumbing fixtures. So it gives you an option not to go to the extreme level, but look at the lower levels as well. So if your project is catering to these two mandatory aspects of rainwater harvesting and plumbing fixtures, you are already achieving water saving with respect to baseline up to 30%. 20 to 30% water saving is anticipated right here. But if the project goes beyond this, if they are doing rainwater harvesting up to 70% or even 100%, accordingly they get points here. So these 4 points come up, but along with that, you will be facing the enhanced saving in terms of your recharge. And if your water efficient plumbing fixtures are showing enhanced savings, you get additional points here up to 5 points. So that is how your saving now rises between 20 to 30. It is now 50 to 60% also. When I talk of net zero water, I am talking of this saving rising up to 90%. When I'm saying net zero water, that doesn't mean that project does not use water. Absolutely no. This is a misconcept. Project is using the water that is required for a comfortable living. We are not starving on water. We are using the water which we require for a comfortable living, but we are reusing the water where it is possible. We are trying to accommodate the same water in the project where it is possible. So we are trying not to take in any water from outside. We are not giving any water outside, maintaining a perfect balance. This is challenging, but it happens. So next thing, when you see about IGBC water calculations, it is nothing else but a calculator wherein you try and put in your daily values in liters per day, and you can get savings out of it because IGBC calculator has inbuilt baseline numbers, and when you put your own numbers it will give you immediate numbers that okay, with flow rate XYZ, flow rate say 5 against baseline of 6, you are getting 10% savings here. So this is the image for water balance daily, water balance annual, and this is the image wherein you also see the plumbing fixture with baseline. I hope that is clear. Yes. So this is the baseline wherein water closet with 6 liters and 3 liters with dual flush, and flushing duration is mentioned, use you have to mention, and accordingly with the basis of occupants, number of occupants, you come up with a number here. Now, excuse me, if you are giving a water closet in your project wherein you have 4 liters and 2 liters as your flush flow rate, here you are directly saving 35% and 33%, isn't it? So this calculators are available with IGBC wherein you immediately see the percentage. Here health faucet 6 liters per minute duration and the number of use. Here they have not used anything less. They are using the same 6 liters faucet, and probably with the enhanced duration they are not 25 but maybe 26 as a by default duration. They are getting -2 percentage in water savings, right? That is perfectly fine because we are not targeting each and everything. If you are giving our hand spray with 5 liters, again you will see a lot of savings. Simple taps with 6 liters per minute, if you are going with a foam flow and your flow rate capacity is absolutely up to 1.5, 1.2, you save a major chunk here, up to 77%. So shower hand spray again. So again consolidating the entire flow chart, you get an annual saving of 45%. So we are talking numbers. One thing you change here, the number will change. I hope I'm clear here. It is clearly mentioned that the pressure at 4 bar, these are the flow rates which are required. So friends, pressure is changing, the flow rates will also alter. Okay. So this was all about IGBC. Now let's see what Griha has to say. Griha is also defining against the baseline, but it says that for a typical number of people, number of units in a project, if we consider that domestic water demand is not 125, not 110, but at 90. So we are firstly reducing. How we are reducing? Again, Griha defines certain flow rates as IGBC is doing it, and on that basis they have arrived at 90 liters per day. Okay. Now water requirement is defined as per your occupants. You come up with a water balance chart wherein you are designing the water system with 90 liters per person per day. We end up defining our STP. So when we are designing STP, we often ask the developer what is the population. With population, we start with a thumb rule. We end up with some number of liters, and we are designing our STP on that basis. We are really not bothered how many people are actually staying in the building. We are considering 5 people per 3 BHK or a 2 BHK. There might be 7 people or there might be just 2 people also staying. So we are not counting at actual, but we are designing the STP on the thumb rule basis. What happens due to this is many of the STPs, they do not fill up, they remain halfway, then they need potable water to fill up and then run the system because the makeup water. So looking at that, we are ideally running the STP at a lower volume, but again spending the energy on the same level as required for a higher STP demand. So why not, instead of over designing the STP, make an additional effort, take out the exact calculation. Now people might ask me कि ये कैसे होगा, because maybe the government will not give you the clearance, or maybe the if suppose today there are only two people, flat gets sold out and five people come here, then what happens when actually the demand goes up? But if the developer is giving the fixtures which are already low flow, if the right awareness is spread among the people and they are told that you are designed for the entire water supply system to use XYZ amount of water at comfort level. Please do not enhance the water use. If this is a clear message given to the inmates, definitely they will be aware. Because today we all are in a way quite conscious about what we are doing, and that is why, ma'am, you guys are making all these efforts for the training and imparting the knowledge. People are already aware, so no harm taking that risk and design the right STP amount so that it does not fail in future. We were doing a research in Pune on if the STPs are running efficiently or not, because we find in our cities many of the STPs are shut off because people don't want to pay the maintenance, and further these STPs are shut off and the entire sewage is going in the drain, loading your municipal system. So the effort of making an STP, designing an STP, constructing, paying the dues, everything goes for a toss. And at the end of the day, when the municipal system is again getting hampered, we end up getting impure water or the unsatisfactory condition of water. So importantly, we need to understand the use and design the right sizes for the system. So that is how Griha focuses upon. It has given the domestic requirement, it has given the flushing requirement, landscape requirement. If you have a swimming pool, water body, it has specified the requirement, clubhouse, commercial use, where people are not very conscious in using the systems. Because when it goes to hotel, we will definitely make it a point. We are paying for it, we use the most out of it. So even in terms of energy or water, we lose our consciousness totally. So it is important to calculate them without savings. And then whatever number comes up, we should define our systems on those numbers. Also talking of LEED. When we talk of LEED, now LEED is a certification body on international level. Now LEED defines this particular the same system with the same flow rates, but I just thought of adding a different calculator here, because for landscape LEED does talk of evapotranspiration rate, the kind of irrigation system you're using, efficiency of system, and multiple other things, along with the type of landscape what you have and the various values of the plant type to give you the right amount of water in terms of landscape and irrigation use. So when we say that we are designing our landscape and we are replacing the potable water use with recycled water, we have again the exact amount of water in terms of percentage in liters as well that we are tackling. So we have similar calculators for water calculation for landscape, IGBC and Griha as well. But I just try to add some variety with different certifications. Okay, this slide was voluntarily added by me for a reason. People might ask that why is certification essential? We can always use these calculators, calculate our own water. Do we really need them? So coming to it, what is the real green benchmark related to? Everybody is telling their own baselines. Okay, so what exactly do we come up? What is the real baseline? If we talk to for this, the operational stage. So you on the start, you are applying all the possible strategies to reduce the water. So reduction is there. Now you have confined to certain certification program or certain baseline and arrived at a number. But after 1 year of occupancy, when you are checking your own performance of the structure, that becomes your baseline. Every time then onwards, it is apple to apple comparison only. So the operational stage performance becomes the baseline of the structures. Now, another question that comes up, if a developer is doing all the green features, is the project really sustainable? So somebody might just come up saying we are doing rainwater harvesting, we are doing STP, we are recycling the STP water for landscape, dual flush. We are, going out of the way and using very low flow fixtures, and we are sustainable. So it's like, self-declared thing. Sometimes it is, yes, possible, but as we saw in the first slide with 5 elements coming up, we need to understand the integration as well between all these criteria coming at a common point, meeting all the mandates defined by that particular program. And if there is no program, you cannot define your own mandates. You have to follow some guideline. And if that is there, definitely you can conclude with your project, but it will be a self certification. It is, I always give this example. It is something like a student is studying for 12th very hard and doing all the possible, taking notes, taking reference of XYZ things, but student says I don't want to give the exam. He's not giving the exam. Can you call him HSC qualified? He cannot declare himself that, okay, I'm 12th pass. So the same logic applies here. But friends, is certification the only benchmark? Definitely no. You can do things consciously, but it proves to be a very reliable and a strong base. And that is why we can definitely look at it. Is certification essential to claim a green building? In 90% cases, it does. It is. Because again, as I mentioned, it comes up with an authentic document that your project concludes to XYZ things. Now, can use of few passive strategies in the structure prove things to be a sustainable design? Now, if I'm doing XYZ things already in my project, can I say that my project is sustainable? No, again, evaluation is necessary. If you are doing any one aspect as well, you have to go further and evaluate it. Unless you do that, it is not a valid justification. So friends, going further, I'll just put off my video. I just thought of sharing one local case study here in Pune. This project, Yashwin Hinjewadi, that is in Hinjewadi, Pune, it is an IGBC Platinum certified project wherein we faced around 50% savings in terms of water, which was quantified water. Now here, how we arrived at this 50%, it was 49.94 something. So we rounded up to 50. 100% water was treated and reused on site. 100% hot water that we were generating was from solar aspect. And not only that, but this hot water, the project tried and emphasized on not letting out cold water previously. So जब भी हम लोग hot water on करते हैं, हम कहते हैं उसको 2 मिनट नल शुरू रहने दो. Only then the hot water starts coming, because let the cold water flow out. That cold water is nothing else but a waste. So their system in plumbing is designed in such a way that you do not get this lag in terms of cold water. Third is 100% rainwater is done on the site. So with your kind permission, ma'am, can I play a small site visit video?
Sure, ma'am.
Sure. It's not yet seen, right? The video is not playing, right?
No, ma'am.
No, it's not. So I just. I'll play at the end of the presentation.
Okay, ma'am. Yeah,
So I have this case study defined here. So IGBC Platinum project, as I already mentioned. So these were the direct measurements that were done along with the plumbing fixtures, and indirect measuring things were native landscape for reduced use of water. So these are the few images of the project wherein we have the landscape. We have grass pavers also supporting urban heat island effect and other things. We have podium landscape. We also have used turf in certain areas, but tried and integrated it with other softscapes as well. And in places we have ground covers. This is the project. So it is also helping the landscape for urban heat island and the reflectivity for heat gain reduction. So the landscape along with drip irrigation systems, the water meters, the flow meters, the pressure regulating valves, and very importantly we have the right signage. So if you can see, this entire is the display board in their common areas where they are displaying how to use different elements which are already strategized in the project with regards to water, what all they have done and how they have implemented the strategy. This is defined here. And because of this, what happens is the end user who's using this particular project, they are aware that the developer has given us certain certain measures in terms of low flow fixtures. So after 2 years, when the flow fixture starts getting stuck with impurities, यूजुअली क्या होता है, 2 साल के बाद कचरा अटक गया तो people call the plumber, they remove the aerator and then they start the tap as is. So they should not be doing it. They should connect with the right team of developer for maintenance as well, who will replace the aerator, or they will clean the aerator properly and replace it for the same amount of water use. Then another issue comes up with rainwater harvesting pits, कि 2 साल 3 साल हो गए कि सब पत्ते वगैरह जमा हो जाते हैं in the entire pit and maybe the water percolation reduces. So pit cleaning also becomes an important factor here. Then water level controller and avoiding overflow of overhead tanks also becomes an important thing. So use of right sensors and time valves also, then sewage treatment maintenance, all these things has to be done properly, and they all make a great ONM, that is operation and maintenance protocol for any project to run successfully. Friends, another important and very important thing about water I would like to highlight here. When we talk of use of water, we all are aware that in a building, how we as an independent person will be using water. We drink water, we take bath, we use it for cooking, we use it for multiple things, cleaning, and it goes on. The list is on. But there is an element of water that we do not see, but that exists. And that is nothing else but we call it as virtual water. It is the water that is hidden in products, services, processes, or just people, I would say. And the end user often doesn't realize that, okay, there is water also associated with this activity. That is the reason this water is consumed, and which is affecting the value chain, and it is making the water as an entity very costly, scarce, and also losing the quality that it should be associated with. So when we talk of what is our water footprint, so if you see this associated picture here, how much water does it take to produce? So in products and production of many things, a great amount of water is actually going in. And this particular water, nobody ideally will calculate unless and until it is, measured by that particular company for a purpose. People will just ignore this particular water. So we need to understand the amount of water going behind each of these elements, multiple grains that we see coming up, multiple processes that are existing in nature. We have moisture, we did talk of moisture, and we did talk of comfort related to the moisture. But we often end up not talking or ignoring the energy which is associated with dehumidification or humidification. So we add certain fountains or water bodies in certain areas so that that particular area remains hydrated. The same way we drink water every now and then to remain hydrated. We give water to multiple small elements around us wherein they do not get measured. So we need to understand, we need to take our water footprint for internal as well as external, for domestic, agricultural, industrial, and whatever products we are using in our day-to-day lives, whatever activities we are doing with water directly and all the more indirectly. So even plants are shedding water. बट जैसे कि अगर हम लोग कोई पेड़ के नीचे खड़े हैं, कभी कभी वी फाइंड द ड्रॉपलेट्स फॉल ऑन अस, एंड इट इज जस्ट ट्री शेडिंग. For kids we often used to say that trees are crying, don't cut them. So there are multiple things. So this element of water goes absolutely ignored. Then the water which is retained in the soil, also we ignore it. So all this water, when we actually measure, we actually count and start respecting them for their conscious use, I think then only we are making a great deal towards this water saving. So for any building, my friends, we have two kind of benefits. If we are targeting the sustainability aspect, we have tangible benefits, we have intangible benefits. Tangible is measurable, intangible is something we cannot measure, but that exists. So reduction in water and reduction in energy are the tangible benefits that are directly associated with any building. While enhanced air quality, better living conditions, daylight, universal design access, waste management, air pollution, materials with the right VOC content, better construction management, वहाँ पे water reduction, many other things along with a beautiful landscape giving pleasure to our eyes, definitely will lie under the intangible aspect of benefit criteria. So green buildings are thus benefiting the end user at individual and society level, and on a major scale to the environment. That is how we are coming back to the three pillars of sustainability that we did talk of, and we are benefiting with one single element of water for a very, very major cause and displaying tangible benefits. So friends, with these few words, I would like to end my presentation here, and we will come to question and answers. Green is definitely profitable, and when we talk of profit, we often talk of money as a profit, but we should also talk of resource and their saving as a profit element. If you can quantify it, you can definitely associate with price, and then you can claim the word profit in the right economical sense also. So go green, it's definitely profitable, and whatever you are doing with water, with energy, try and quantify it to the right level so that you can claim the number that is associated with that project. So before question answers, I think I'll just show the video that was associated. Give me a moment, please. I think that's not getting displayed.
Ma'am, I think your screen has got unshared now.
Yeah. No, but that's not coming in the share window at all, so I could show you. I think yes.
Yes, ma'am. Now it's visible, ma'am. Ma'am, when you, I can actually, is there some voice in the video also, ma'am?
Yeah, but you can ignore that voice. It's very low.
Okay. Ma'am, you have worked with this group.
Yes, that's one of our projects. So the toilets have the disabled friendly approach as well.
Ma'am, in terms of cost estimates, these buildings might be a bit costly, right?
Not at all. Not at all.
So these are all competent with the other buildings as well.
I would say the other way around. It is on the lower side when it comes to, when it actually comes to the right working. So when it is working, the project turns up to be benefiting in terms of your reduced water usage, reduced energy usage, and that is how you end up saving a lot of money here. And ma'am, since you mentioned this, I would definitely highlight that my doctorate thesis I did on cost implications in green buildings, because this question that you're posing today, whether green buildings are costly or not, this question was hitting me every now and then in my profession. And people were just coming up with any damn numbers कि हाँ 100 रुपए बढ़ जाता है 50 rupees बढ़ जाता है. Then people started also mentioning that if you're going with gold you end up paying 500 more. If you're going with silver it is 50 rupees more. So when I did my doctorate thesis I actually took around 15 buildings, studied them in terms of their actual implementation of green strategies. So there are multiple factors which are associated, and most of these factors depend on the quality of construction of a developer. If a developer is doing good job right from day one, he will end up benefiting absolutely a lot from these green buildings. But if his original work quality is compromising, then they keep on struggling with every aspect. So if you are putting aerator in any tap, the aerators will cost you between 70 rupees to 150 rupees. Now, these aerators are available with actually every fixture that you opt for. अगर आप जगवायर लो, आप कोई भी फिक्सर लो, it is available in the market. हर एक फिक्सर में aerator आएगा ही आएगा. Just that you have to define the right aerator to that person. He don't give me this aerator, give me an aerator with XYZ flow rate. Now it is the wisdom of the developer whether the company asks him for more amount for that replacement of aerator, or they go on the same amount. So when they are ready to buy a tap of 400 rupees, they can always ask the company to give them the right aerator. And when they are replacing the aerator, the original aerator also is for 100 rupees. So ideally it will not cost you anything. Then putting the rainwater pits in the right fashion. अगर वो developer पहले से ही ये कर रहा है, so this is not any burden to him, right? So if they are not doing it at all, they have been managing with all rules of MPCB, CPCB, whatever comes up, because this is not a green building requirement. It's a conscious requirement for any construction. Similarly, if you're doing STP, if you're not following under the bracket of STP, still you are additionally giving an STP, then that is a cost to you. But if you're already having a large area where STP is a mandate to you with corporation norms, this does not lie under green buildings. Okay, so green building will mandate you to use it, to maintain it. And I don't think so that's a cost. If a company is installing an STP for you, they will definitely give you the maintenance also. So that goes along, and I did conclude about it that it is a matter of your own choice, how you approach it. So there are examples with me wherein we have the return on investment for commercial projects, absolutely within 4 years, wherein they have installed 125, 140 kilowatts of solar, and they are net zero also in terms of energy. They get the energy bill with the number 0 and minus 1200 units or something like that. So this is a profit. They are not energy negative or energy neutral. They are energy positive projects. Similarly, there is water positivity also. There are some projects where excessive water they are available. They don't know what to do with it. And Dr. Devanshi, as I mentioned, this one question I would like to pose to everybody in this audience, that I am facing this issue that with green buildings, we are struggling to give the right plantation so that we don't use too much of water in our landscape. We are giving dual flush and reduced flow fixtures so that we don't use too much of water in dual flush, while my STP is generating excessive water. Okay, and if that water is excess, what do I do with that water? I have tried asking this question to multiple committees, multiple government authorities. People come up with answers like wash your car. But if you wash your car with this water, it is having certain metals and elements which will destroy the cover and the color of your finish of your car. So that is not right. What do we do with this excess water? Okay.
Ma'am, what is the quality of the excess water?
It's treated water.
Basically, what मतलब सब कुछ impurities तो रहेंगे.
Tertiary treatment.
So it's completely pure that it can be reused?
Not at all, because it is coming out of STP. And
Okay.
for Indian conditions, we do not have that logic of reusing the STP water for our day-to-day purposes. And it is not advisable as well.
Ma'am,
So
it can be either it can be used for some plantation sort of where you can like create a garden or some flowering plants which are basically not directly consumed.
So
So
जगह
that
कहाँ
can
है
help.
उसके लिए? People are using the plantation to optimal, and we are already using the water for landscape, for dual flush, for even चलो car wash हो गया. फिर भी there is excessive water, and the conclusion that has come up is throw that water in the drain.
But it will ultimately again be into a bad condition if you throw it.
Absolutely. So this is the problem today, and it will be an excellent thing if something can be done for this thing. This
Ma'am, can it be used for groundwater recharging as also?
not really, not
But
really.
because when we pass that water from the ground acts as a filter it by itself.
Yes.
So maybe it can be used for deep water ground recharging.
No, no, I don't think so because it will contaminate the reservoirs.
Okay.
We cannot do that. It is not allowed because our tertiary system will not have that level of purity with the water, and it is not allowed to destroy the main reservoirs
Okay.
with this. So it ends up going in the reservoir but through a different way, which is again not right.
So any of the participants, if they can suggest what can be done with the excess water which is coming from the treatment plant in this green building certified areas. Anybody can come up with any view. We would love to have something, some feedback from your side.
I think this is having this issue.
Participants, please, if you want to give some feedback regarding what could be done with the treated water, any new ideas? So, ma'am, probably they don't have the solution either.
So of course this is a research topic then.
Definitely,
The
ma'am.
budding people, they can actually look at it.
Ma'am,
And
someone has commented that it can be used for groundwater and can be used in some fecal, something like that.
facade
Facade
cleaning.
cleaning.
So facade cleaning. So facade cleaning also, the water needs to be tested with regards to it is not going to hamper your glass or any of the aluminium surface. अगर वहाँ पे कुछ facade cleaning के options भी नहीं है, it usually happens with the residential projects wherein we have around 500 units, and the STP is over designed as always. People just use the water, and the water is in excess because most of the flats remain closed, and we don't consume so much of STP water as well. And this entire water goes to the drain, further going to the nala, and it is joining the later reservoirs, which is a sad condition actually. So,
Ma'am, grass crops is an option suggested.
mhm.
Grass crops.
So that is cow feeding.
Yes, ma'am.
Um, Again, there is a problem. So we did explore all these options. There is a problem of our tradition here, that वो
But
पानी
ma'am,
कहाँ से आ रहा है वो भी एक
yes, ma'am. But ma'am, outside India, they perform this treatment to such a level that they can
yes,
use it in drinking also. So
absolutely,
I wonder how do they do?
थोड़ा सा वही ट्रेडिशन का फर्क पड़ता है मैम वहाँ पे. But I'm glad people are responding to it. And yes, for construction activities, and we have been suggesting the same to the people with the right quality of water. If it is acceptable, it can be used for construction. And there are multiple developers who are exploring the option of filling up this water in tanker and giving it to the right resource. जहाँ पे पानी कम है उनको कंस्ट्रक्शन के लिए चाहिए, या फिर some areas where they do not have STP, जैसे कि bungalow societies है, where independent bungalows cannot have STP, so they make an integrated tank outside their colonies, and this excess water is filled in this particular tank where they can use it for their flushing and landscape activities. So growing crops and agriculture, we do not prefer using this water, again with the same conditions that थोड़ा सा tradition आ जाता है बीच में, and culture doesn't permit the fecal water to go in the food areas, and of course the checking for E. coli and multiple things are to be done before using this water. So okay, RMC works indeed, yes. STP में मेकअप वाटर के लिए भी यूज होता है, बहुत सारी जगह यूज होता है, and it is found that when we make this water balance chart, still around 5,000-6,000 लीटर excessive water बहुत जगह निकलता है, which is a big deal. So yes, I think people can go ahead with their questions if anything.
So participants, if you have any questions or doubts that you would like to be cleared by Anshul ma'am, please type in, or you can even unmute yourself. So I suppose, ma'am, we cannot have any questions as of now.
No. Yeah, because the time also is calling.
Yeah. It's almost time, and people have responded to your question. That was a very nice part of them.
Yes.
That at least they paid attention to what you were saying. I thank you so much, ma'am, from on behalf of the IPS Academy, Institute of Engineering and Sciences, Civil Engineering Department, for being here today with us and enlightening us over such important issues of the green building. And the way you presented was very nice, ma'am. I cannot there were no words. In fact, in between the presentation, also we had compliments that it is an excellent presentation. It is the way you bring forth the concepts that really matters. Thank you so much, ma'am. We look forward to having you with us sometime in person in future.
My God, that's a pleasure, and nice to hear such words. Thank you so much for this opportunity. And yes, we are craving to move out in public now.
Ma'am, I would like to know, do you have some options for like newly graduate students from the civil engineering background? If there are certain opportunities, please do let us know so that we can help them out as well.
Absolutely, I will. I will. Thank you
Thank you
so
so
much.
much, ma'am.
Thank you for the lovely participation, audience. Wish you all the very best. Have a great day. Have a green day. And be water conscious always. Thank you.
Thank you so much, ma'am.
Ma'am, can I log out?
Good evening, ma'am.
Good evening, ma'am.
Ma'am, just let me know when we are ready to start.
Yeah.
Ma'am, should I introduce you first?
Yeah, you can go ahead and we can start. That's not a problem.
So, welcome back to this AICT sponsored 1 week short term training program on water quality complication, restoration, and environmental conservation of existing water bodies. Module 2. We have with us Rohini Pradeep ma'am. She is a project manager at CDD Society, Consortium for DVATS Dissemination Society, Bangalore, Karnataka. She is an environmental engineer with a diploma in industrial safety and certification in environmental planning and management from the Center for Environmental Planning and Technology in Ahmedabad and FSM course from AIT Bangkok. She has over a decade's experience in the field of environmental monitoring with a focus on performance assessment of wastewater and fecal sludge treatment systems. She heads the CDD's laboratory along with the coordination of research and development activities. She has worked with teams on the design, implementation, operation, and maintenance of numerous DVATs water body rejuvenation projects, and fecal sludge treatment systems in different parts of India. I thank you, ma'am, for being present here with us today, and especially thank you for taking out time of your busy schedule and accepting our request and invitation, ma'am.
It's
We
our
are
pleasure.
we are indeed privileged and honored by your presence, ma'am.
Thank you. Thank you so much.
And ma'am, I request you to please start with the session.
Sure. I hope all of you are able to see my screen.
Yes, ma'am.
Okay, sure. Okay, let me just. Sorry, it is got 1 second. Okay, until it starts, like as ma'am introduced, my name is Rohini. I'm a project manager at CDD. Just to give you all a background about CDD Society, CDD is an NGO based in Bangalore. We mainly work in sanitation sector, sanitation, water, and all. We started in 2005, mainly as a registered in 2005, but we were existing before also, mainly looking at some low O&M or a low systems to treat the wastewater. So they basically started with our German colleagues who came from Germany, started this whole NGO. We have more than 25 partners across India who we work with them in the implementation of all these water and sanitation projects. Coming to water body, this is not too, I would say we have a lot of experience here, but last, I would say 5 to 6 years, our experience has been in the water and sanitation sector. We come from, as I said, the sanitation background, wastewater treatment, wastewater management. With the same concept, we also started working with the water bodies. So what I'm going to present you all is our last 5 to 6 years, our experience in working in water bodies. What do we see as a water body? What are major challenges? How we can look into it? And what are solutions? So I have some key projects that we have done. I'll give you also a case study and a small video about one of our case study that maybe will give you little more information about all our projects that we have done. Coming to water body rejuvenation. So today my topic is also is like water body rejuvenation, a nature-based approach. So why nature-based? I think most of you come also understand nature-based. Basically, we CDD are mostly promoting a nature-based systems. We believe in nature-based system because it mimics the nature, and because it mimics the nature. So for you, for a users or whoever adopt it, it is not that difficulties in managing it, and not much operation maintenance, not much external energy that is required. So nature based, which mimics the nature, has been our approach, and whether we work in any of the sector, that is something that we follow. So I think starting with, I think most of you have seen this scenario of water bodies. This is not new to most of you. Been seeing everywhere, whether it's a newspaper, whether it's a TV channel, or whatever you have seen water bodies that you see. Today, our water bodies are suffer from multiple answers. It's not just one problem that we talk about. There are many problems that are really today our water bodies are associated with, and these problems are not easy. So maybe you just show, if you look at from a from a just an outsider angle, you will just say, okay, what is there? Is you just clean the solid waste? Okay, this time the water bodies are clean. It's not true. The problems that today water bodies are ongoing is very complex, and they are intertwined. Like what is that? I'll talk in the next slides. But this is, please remember that water body is not, when you talk about a solving or a rejuvenation or cleaning water bodies, it is not that easy. And it is not also like, okay, if I clean this tank, everything is fine. It is not like that. So there is a long process that we need to follow. So to start with, okay, then what are those problems that our water bodies are getting it? So the key problems or key challenges that we see today is that, I think most of you are aware of it, the wastewater issue. Today, I think all of you know water bodies are the major source of water for us. Like if you take any of the lake or any of the water bodies in India, they mainly used to be a source of drinking water, or irrigation. So that these tanks were built because of these reasons. But today they are ending up with a wastewater. Means they are just a bowl of a wastewater that receives the wastewater from a nearby city or nearby village. Basically, it's the lowest point where your wastewater is get deposited. Solid waste. Solid waste is another thing that we all know today. What is an issue? There is also an infrastructure challenge. I'll talk about all this individually. Social and livelihood challenges, data and information, and majorly the weed and silt challenges. Anyways, when I say weed and silt, it is somehow linked with your wastewater and solid waste problem. See, when it comes to water bodies, right, one thing to very clearly say, as I said, wastewater pollution is something that we always see it's a major problem. Our experience has been, see, always wastewater is a solvable issue because it is again, discharged by one city or one factory or one office or whatever it is. So it is usually solvable issue. So the majorly our activities, the human activities are the one who are actually sending the wastewater. So somehow if you can able to tap it and then clean it, that's an easy thing to manage. You can always just stop that. But what is issue that we face is that more than a water or a wastewater, it's a solid waste. So the problem is that, it's also again from a human activity, but the problem with the solid waste is that it's just not dumped on one place. It is being dumped at every part of water body. If you're managing any water body, now first thing that you have to look at is the solid waste. If you're able to manage solid waste in that particular water body, you're very clear that your water body can be easily clean. Once it is, when you talk about solid waste, it's just not that plastic that you see. When these plastic materials stay back in the water, when it start also degrading in a long run. So if there is a small microplastic that we all talk about, they start leaching into water body. These microplastics will be there in the water. If it is a long retention, they will start accumulating in your soil. So the problem is just not in the water, it's also will finding in the land that is finally ending up in. So that's where I see wastewater is something that you can always solve, but solid waste is something is a major or a greater issue than our wastewater problem. So weed and silt, as I said, it's again linked with our pollution problems. So if you are able to manage your pollution that is coming in, you will be able to manage it. It's just a one-time kind of a thing. Once you stop your wastewater or a solid waste that is entering into the tank, you can easily stop this weeds and silt. Then the lake will be free of weeds and silt. Coming to infrastructure. When I say infrastructure, it is not that something big, just that the inlet that water that is entering, the storm waters that are carrying the water to the water body. So where the water comes to the water body, one is that water that falls onto that surface of the water body. Second thing is that water carried by all these small drains, or it's a big drain, could be like over a river case. You can think of big drains, a storm water drain, which are bringing the water to the water bodies. So basically, these are the major source of water. Today, they also have become major source of pollution. So basically, they carry a lot of pollution, whether it's a wastewater, whether it's a solid waste. And then all these lakes typically, if it is a properly constructed lakes or you will see there is an inlet and outlet. I think mostly if you are all with a civil background, you may know about these culverts, inlet tanks, and there is a surface surplus weir. So there are a lot of infrastructure that are existing in the water body if they are constructed properly, and there is a bund. So today, if you look at it, major issue has been all our inlets, the infrastructure that present, either it is in a bad condition or it is clogged. So when we look at water bodies, it's just that you will not look at only as a pollution angle, you also have to look at what are the other infrastructure that is existing in the water body. So these are some of the problems that we see. So I think if you recently have seen a lot of that water bodies that are overflowing, the major issue not just because of a pollution, it's also because of the bad construction or the weak construction of the outlet of the tank. So you all heard about it. The weir got demolished, weir got destroyed. Because of it, the water actually came into a nearby apartment. So all these things also happens because of the infrastructural problems. Coming to a social what you call it as, I can simply say, let's say a social problem. When we talk about water body, there is always, we talk about encroachment, because the encroachment is not, you can't really quantify in terms of what kind of encroachment. It could be like a people like big builders to a small slum area also. So the lake water bodies are mostly encroached by the small people around the water bodies, because the water is available. You all know how our civilization has grown. So where the water is there will be a lot of people are coming in and then they are settling. The same way here also, when there is a nearby, there is a water body, people start, start their livelihood around this water body. So when we talk about any water body rejuvenation, right, you need to tackle this problem. So that's where water body, a lot of projects actually get stopped. Any development activity that you start with water bodies, the majorly issue has been the encroachment. And how do you solve the small livelihood people? Like there are fishermen who depend on that water body. There are like farmers who are depending on taking some water from the water body. So there are a lot of livelihood also depends on this water body. So hence, when we talk about any water body rejuvenation, taking care of all these small things become very important. Coming to a solution. So these are something what you can see that these are the challenges. So what is then solution we need to look at when we talk about, okay, if I want to rejuvenate, how do I go about it? I know there is wastewater, I know there is a solid waste, there is an encroachment, there is silt, there is infrastructure problem. So I got to know what does need to be done. So first thing that we have to do is that we need to reimagine our water bodies, because until now, water bodies has been the major source of water for drinking or for a irrigation purpose. When it comes to an urban condition, maybe this may be true even still for a village or in a rural condition, but when it comes to urban, so basically we need to really rethink about the water bodies, that what is that I need this water body for? Where do I use this water body? Am I going to use this? I'm sure if there is something that water has been polluted, or even you ask any nearby community saying that, okay, I'll rejuvenate, I'll give you clean water, are you going to use it? So the mostly answer is going to be no. I may want to use it, but I don't want to use it for drinking purpose or for my any of the domestic purpose. So hence you need to reimagine that the water bodies that going to be rejuvenated, for what purpose I'll do it. Am I going to solve rejuvenate this water body for a recreational purpose? Question mark. Or should I look at my water bodies for just because all of you know about it, by bringing a water body to the life, there is always an that surrounding, especially the surrounding area, will have a better climatic condition. It also increases the groundwater level nearby. So look at what is it exactly you want to, what is your objective of rejuvenating any water bodies. So start from that. I will decide what will be my water body that I'll be working for what. How do you decide? Obviously, you will not be alone doing it. You need to look at who are the stakeholders that is involved in this particular water body. When I say stakeholders, it could be simple fisherman, a government who will be owning that, could be a revenue department of that particular urban area, then the community around the lake, the people who are depending on this water body, it could be what farmers, as I said. Bring all of them together, ask them what is it exactly they need. So basically, see that, and also one thing that we all have to remember is that water body rejuvenation is not a copy paste work, like how we design other civil engineering things, right? Or an environmental like wastewater treatment, water treatment. There are no such standards that are existing for water body. There may be there, but you need to really rework or you need to remodify based on your water body context. So basically, by bringing all the stakeholders, form a solution that is suitable for that particular water body. How do you start with it? As I said, bring all of them, ask for what do they really need. There are, when I say stakeholders, not just that like people who talk. There are also biodiversity involved there. Like there are a lot of birds that are dependent. There are a lot of fishes that is existing. Obviously, you can't go and ask them, but just ensure that we are not going to disturb their environment. So ensure that any water body that you are looking at, you take care of all these aspects and then decide on what do I do it with. So once you decide that these are my solution, this is what I want the water body to be rejuvenated, we'll first start with understanding the water body, right? How do we do it? The whole approach, we think when it comes to water body rejuvenation, it has to be an holistic approach. It starts from different data collection. What kind of data that we collect? Starting from what is the water quality, what kind of a silt that is existing in the tank, what kind of biodiversity already existing. When I say biodiversity, it's a flora and fauna, just not a animals or a birds and all. Everything that is existing, biodiversity, what kind of hydraulic structure is existing, what is that livelihood or what is the socio-economic condition of that particular land use. This is particularly related to a catchment, means what is there and what is that urban area or a rural area existing in the upstream of that particular water body. That is completely actually that is what is giving you the water, that upstream. So your upstream or a catchment area characteristics become very critical to plan any of the rejuvenation. So tomorrow, you know that upstream, like you are cleaning the water body, but you know that upstream area doesn't have sewer line. They will be finally ending up all their wastewater into drain. Then even after cleaning or creating any good bunds, everything, your water body will again, receives only wastewater. So the catchment analysis, catchment area, what kind of characteristic that has become very critical for any of the water body rejuvenation, means what type of, whether there are industries, there are only households, is there any lot of forest land. So all these things need to be studied to understand what is the contribution of this catchment area to my water body that is we are going to work on. That is the data that you need to collect. On the top of it, there are different legal framework, who is community. So once I'm done, okay, there may be something that you need to, because finally who will going to take care of it? So probably the people who are locating nearby only. So talk to community, create an awareness that you don't need separate an organization who will be take care of. The community itself take care of the whole water body. Finally, anything that you create, it has to be sustainable, because just because there is some money existing, I'll just invest on civil structure is not going to end. So you need to also ensure that whatever you invested on the structure should also be there for a longer duration. So a lot of this data need to be collected, bring all the stakeholders. This is one of the example how the catchment analysis is being done. So you see here the blue color one, this is the water body. When we talk about water body, as I said, what is there in the upstream become very important. Whether it is what kind of catchment area, whether it is still, maybe you can use a lot of this. I think most of you all aware about GIS. Use the GIS tools to understand what is there in the catchment, whether it is what it used to be earlier, what is today, which are the drains that is contributing to this water body. Do this analysis and find out what is exactly there. So it includes what kind of data that we look into is the first is topography, where are the drains, how they are connecting, geology and hydrogeology in terms of how much water is coming in, what is the soil characteristics, what type of catchment is it like a built up characteristics or is it only a fully of vegetation. So look at every part of the catchment area and then compile the data, and then we'll be able to identify, okay, this is what that we are going to get, whether it's a water, whether it's a wastewater, or is it a solid waste. So decide based on the catchment area on what is it going to come to water body. These are some of the pictures of, once all these things are there, how do we collect the data? What, like in terms of water quality, in terms of infrastructure. So the first picture that you see, this is mainly to understand the percolation. So why do we do percolation? As most of you know, water body, it's not that water body is like, as I said, it may be a bowl, but the bottom is always there is a percolation. So in order to understand if I'm just so much of water is coming from the catchment area, whether how much water is going to get lost because of the percolation. So in order to find out that, we do percolation test in the bed of in that lake bed, so that we know what is the percolation rate. This is the flow measurements. So basically, it shows how much flow, how much wastewater is being going to the water body. This is basically a velocity meter. It tells you like meter cube per hour or meter cube per second. That data is available. From that, you find out what is the wastewater contribution from that particular drain. Same thing. These are some of the data that is collected to understand what is the characteristics of the wastewater. Typically, for our water bodies, we do collect sample like 24 hours. So there'll be some person will be there from morning to evening till almost 24 hours. Every 2 hours or 3 hours once, we collect the sample and then study what is the characteristic. So this is one of the site, one of the drain where we took a samples at the night time. Then it's again another flow measurements, and this is the infrastructure that is existing. So we measure what is the depth, what is the current condition, is it in good condition, what are the major issues. So all these things visually you will start recording it. So coming to quality, for a concern from a water body rejuvenation, there are three or four things that we look into it. One is pH. Typically, if it is a domestic upstream catchment, then we don't need to worry about it. But if there are industries are existing, so probably what you get is a little high, chemical nature, and hence you may have little bit of an acidic or another extreme, like a lot of basics, like if there are a lot of soap industries or a lot of other alcohol based industries are there, so your wastewater that is coming in will be of a varying pH. So when there is a varying pH, it will not allow for a biodiversity to grow in a water body. So from that point, it is important to understand whatever the inflow that is coming in, what is the pH of the sample. Then is oxygen demand. I think most of you heard about this BOD, COD data. So typically we measure this BOD, COD to understand how much the water is polluted. So the organic matter is an important factor in any of the wastewater treatment. So there are also set of standards to say what should be a water quality for a good water body. So there are like, you can say it should be less than 5 BOD if the water in the lake is less than 5, then you always can say that okay, the water is good. It is it can be usable. Or if you're looking at a wastewater, let's say if a wastewater in a drain that is coming and joining the water body, if that COD, BOD values are high, then it's very clear that you need some kind of a treatment to be adopted for treatment to be adopted before it enters to the water body. DO, dissolved oxygen, this again important for all the biological activity in the water body, like a fish or any of the biological activity. So you will do the DO measurements. Last thing is the nutrient, because most of you know about it. Our lakes are mostly eutrophicated because of the nutrient that is coming in a wastewater. Understanding how much nutrient is existing, that is in terms of N, nitrate or ammonia or a phosphate. So these values will be studied to decide whether water is in a which condition, means the water body is in a which condition in terms of the pollution. So these parameters are studied to see, okay, whether the water that coming in needs a treatment or the water body require any further interventions to treat the water that is coming in. These are the key parameters I'm saying, but there are many other parameters. If there are any industries that are coming in, then you have to look at heavy metal concentration also. So based on type of wastewater that is entering, you can select the parameter, but typically these are the common parameters you can refer and test the water samples for understanding the water quality. This is on the water quality, sediment quality. Typically, what happens, I think most of you know, usually any of the organic matter or heavy metal, because water body gives a lot of time for settling. So a lot of these heavy metals or a lot of nutrients get settles in the bottom of the lake. So if you take that silt and then test it for a different component, you will be able to tell also, maybe the water looks clean, but if you look at the sediment, of the water body, you will be able to really tell whether it is polluted or not polluted. Typically, it is little tedious job. If it is a what you call shallow tanks, then shallow water bodies, then it's easy to conduct. But if it is a really a big, deeper tanks or deeper water bodies, it takes a lot of time to find out the procedure, doing it because it's a deeper. So little challenging is there, but however, this is one of the common method used in a sediment analysis also to see whether how much the water body is polluted. Biological diversity, as I said, any of the water body when we are studying it, understanding the kind of biological organisms that are present also important. So whether what type of birds are there, fishes are there, different type of plant species that are existing become critical for us. So that because why I'm saying this is that any interventions that you are going to introduce in a water body will directly affect on these aquatic systems or aquatic organisms. So we need to really study, understand, and then based on that, you need to suggest your interventions. Specifically birds, I think most of you know a lot of our Indian water bodies gets migratory birds from outside. Based on the climatic, you will see that like different birds are coming. So when you intervene with the water body rejuvenation, you need to ensure that you are not disturbing the whole their cycle. So if let's say if that lake was not used for recreational, not much of human interventions are there, the birds will be there. Once you introduce a human intervention, like let's say the water body is being open to public for walking, so there'll be a lot of noise will start coming in. If you allow vehicle movement inside the water body, then there's a lot of noise going to come. So then that afterwards there is no birds is going to come. So a lot of such experience that has happened in. I actually, most of you know, like as I said, we are based in Bangalore. There are a lot of such examples are available where they have done beautiful water bodies, means rejuvenated, but it is really affected on the overall the birds, migratory birds coming in, the kind of fish species that they have. So that is also affected a lot. So hence, any water body rejuvenation, as I said, please understand the biodiversity. Accordingly, we have to work on our rejuvenation plan. So as I said, this is something that when we have all the data, we are going to use it to understand what is the data that will be presenting it. So something we do is something called as a water balance. So basically what it does is that it shows, as I said here, what is the contribution of the water from the catchment area. That is, could be precipitation, that could be surface runoff, or any drain that is, or a wastewater. So you look at what is coming into the lake minus what is the losses that happens in the water bodies. It could be percolation, it could be evaporation, it could be evapotranspiration, or it is something directly used for some, let's say, drinking water per se or agriculture. The losses will be minus is equal to what is that finally going to stay in a water body. Means what is the volume of water that is going to stay in a water body. For any of the intervention design and an hydraulic structure to design, water balance become very critical. So based on that, you will decide on what should be my water body sizes. So there may be water, many times what happens, the water bodies are so big, but the contribution from the catchment area or a rainfall may be less. So that cases, so you will not get an additional water. So it will be always like only one part of the water body will have water, other part will be completely dry. Or you have so much water is coming in, but your lake has only less holding capacity because it is not consider all the contribution. So hence what happens, the water, like especially during the rainy season, they just overflow, floods the nearby area. So when we do water balance study, is to study almost all contribution of water that is coming into the water body and what is the losses that are going to happen. Based on that, you will decide on what is the water body or a water tank volume. Accordingly, you fix inlet, outlet to the water body. So this becomes very important study to start with any of the interventions. So these are, I would say, water body rejuvenation points, and these are some of the methods that we typically use in our organization to start with water body rejuvenation. Next, I have some of the case study to explain. But before that, are there any questions from audience so that I can take it up before I get into the case studies part?
Participants, if you have any questions, you can unmute or you can even type in the chat box. Ma'am, I cannot see any questions in the chat box as of now.
Yeah. Okay, if not much, should I go ahead with the case studies?
Yes, ma'am.
Okay, maybe we can take all the questions at the end. Uh, if it is anything that you will not understand, please ask so that I'll be able to explain it. Because with the time that I'm going little faster, I know. But anything that you all didn't understand, please ask me. Okay? Yeah. So coming to case study, I've taken two case study that I'm going to explain it to you all. So this is one lake in Bangalore. It's called Mahadevpura Lake, which is just next to the one of the IT SEZ. It's called Bagmani Tech Park. So this particular lake that you all see here, the big building that you see is all like Amazon, Dell, everything big. I would say all IT companies are existing in it. So what happened was same thing. The lake was completely filled up with wastewater, and the BBMP, that is Bengaluru Bruhanagar, no, Bruhanagar Mahanagar, sorry, Bruhat Mahanagara Palika, have actually taken up this lake for rejuvenation. What they typically they do is that they divert all the wastewater. That is, there are like many inlets to the lake, so they divert this whole lake. What is the wastewater that is coming into the lake, and then taken into the downstream, so that there is no wastewater is entered. So once it is diverted, what they do is they create all bunds, inlet, outlet structure, everything they collected. But the wastewater was not coming, but the lake was completely dry. So they even the rain that has like whatever has been coming from a catchment area was not sufficient. So hence, what they did was the nearby, IT companies and all approached us saying that why don't you do an STP for one of the inlet so that it can be treated, and so that water is available throughout the year to fill the lake. So that's the main idea why this the STP was set up. This was completely funded under CSR grant by all these IT companies. I have a small video. I'll just play that. Maybe then we can have, take up the questions or any thing that we can discuss. Just give me a second. I'll just play a video. Is it visible?
No, ma'am.
Okay.
You can see the presentation.
Sure. I'm just now.
Yes, ma'am.
Okay. Yeah, so that's about the video that I was talking about. So, so when we talk about water body, it's just not, as I said, will not only a civil structure comes in. So there are a lot of components that is involved. So as I said, this whole system is completely nature-based system. No chemicals or no energy is used, and it's a 1 MLD a treatment plant which takes it from an open channel, treats it and put it back to a lake, so that lake will always have water. Then it is, as I said, completely CSR funded. You all saw in the video, and it's simple system. So like just a operator goes once in 2 days, just check whether system is operating. Is there any blockages and all? It clear it and come back. So it's a simple system to manage. Something that is being recently everywhere is being implemented. So this is just a background, whatever I said, what BBMP did and how it was taken up. So the second case study that I'm going to talk about is something called Coimbatore. Most of you know about it. It is one of the city in Tamil Nadu. Basically, again, Coimbatore got a what do you call a lake system, which is very dynamic. There is a river next to that. It's called Noel River. As an this was built very very long back, where when the rivers rises up, the water from these rivers is taken into a city through a small lakes. So there are like series of 9 lakes in Coimbatore city, which used to be a major source of water for irrigation, but because of today's urban growth, all these lakes were filled up with sewage. So the lakes, if you look at it, they're like very small also. When I say small, it is like 100 acre to 400, 500 acre. Very big lakes also were existing. So what they did in Coimbatore is that typically, I think most of you know, under smart city, a lot of projects are taken up. I think Coimbatore is one of the city where they took lakes as being a major part under smart city. They actually called a tender to look at how can we improve these lakes, because they're already filled up with wastewater. How can do the rejuvenation and also create a recreational place around this lake so that people can be brought back into the water bodies. So this is like, you can see the whatever you see, this is the image where a lot of these water bodies are connected. So this is like what you see in the other side. This is something that our plan that we prepared for. So there are some of these 8 lakes. This is how the whole lake has been visualized, and some of them are already under construction. So this is one of the lake you can see here. So there is the whole bund of these lakes have been converted and made it as a recreational place. So this is like a people who come in the weekend, spend their time. It's just not a bund. You also will see there is like the second picture in the top that you see, that you will see a lot of treatment, wastewater treatment also taking place along with this bund. So it is both wastewater treatment and it is a recreational place integrated so that the public actually come and use it. So there is a clean water available and a clean place available for people to come and spend their time. So when I talk about recreational, this is the other way to look at as a recreational. Recreation is not just a boating. You can also bring in such kind of a water park, water theme park, so that it can bring the community back into water body so that it is protected also. So one of the, I would say, how this whole system that we integrated in Coimbatore also to bring in all the biodiversity. So there are like different parts of the lake has been prepared, designed it in a such a way that there are parts where not much human movement will be there. Only sides of the lake will be, especially the bund side will be used. And in between there are a lot of bird islands were created where the birds can come and stay so that they don't get disturbed with the human movement. So those are some kind of different kinds of different levels were created to support different biodiversity. So these are 2 case studies. Coimbatore, you can actually, there are yet to be implemented, only few have been done, but the work is ongoing. So as a conclusion, I would say, see, any of the water body we talk about it, there are no quick fix. When I say no quick fix, it is a long process. It's not just, okay, today I create a structure, tomorrow the whole water is filled up. So it's a long process. It needs time. Rejuvenation is not a one-time activity. It's a long run time. People participation become a key in any of the water body rejuvenation. Today in Bangalore, or I think many of other cities also in India, where a lot of communities actually driving the lot of water body rejuvenation. So bringing back people into water bodies become a key goal of any of the water body rejuvenation. Then you construct it, you have the systems, but if you don't maintain it, they may not be sustainable. So O&M become important. So for that, you don't need to bring in high experts and all. Bring in some of the local people. It could be community. One example, think of a fisherman. If the lake has a good bigger lake, then you can bring in a fisherman who also can create his livelihood around this water body, and also he will be able to maintain the water body because he needs this water body for his fish growth. So he will ensure that water quality is improved. So bringing people, bringing the O&M as a part of your any of the designs, and looking at a long-term solution become an important criteria for any of the water body rejuvenation. These are the key points I wanted to say. Now, if there is any questions or anything, I'm happy to take it up.
And the participants, if they are wanting to ask anything, please you can type in the chat box or you can unmute yourself. Ma'am, I have a question.
Please, ma'am.
Ma'am, you said that this was a nature-based approach. So the sewage treatment plant, which was in the Bangalore case study, what were the components of that treatment plant?
Okay. Sure. So when I say nature-based system, so we promote a biological system which is anaerobic in nature. So there'll be like you all know septic tanks, right? This is like next improved version of the septic tank that are designed, where the wastewater when it comes, it will be organic matter will be there, the BOD, COD, get treated in anaerobic condition. We use wetlands, so the whole tertiary treatment has been put in the water body itself. So there are some inlets, the land was available. We planted some of the plants and also we created a floating wetlands. Like you create a bamboo platform where the plants are grown and they introduced nature-based the plants that are existing who can uptake the nutrients. The whole system was completely nature-based. You don't need to add any chemical. You don't need to add any microbes for it. So it does all works naturally because there is naturally existing bacteria in wastewater, as you know. Based on the condition, you will be able to, that bacteria will grow. So when you provide an anaerobic condition, anaerobic bacteria will grow, they will treat the wastewater. Same thing with the wetlands. We use microbes, that is natural available microbes and plants to treat the wastewater. That's the process that is involved.
So ma'am, how long does it take to treat the water in that plant?
Okay, so anaerobic systems are typically in the range of like 2 days to 2.5 days. That's the overall retention time will be.
So ma'am, the treatment pattern was like preliminary, then primary, then secondary, and then tertiary.
Correct. So because as I said, this particular tank that is the inlet is on an open channel. We get a lot of solid waste. Second thing is a lot of grit. So the whole system is that in the drain itself, we created the series of screens and a small grit chamber where a lot of silt that get accumulate there and clear water comes, means better not too clear, like at least let's say a 10 to 15% is treated there only and then it comes to a sedimentation tank. So there again, if there is any further silties there get removed and then that is all primary. Secondary has been majorly anaerobic treatment with an anaerobic condition takes place, tertiary being wetland system.
Thank you so much, ma'am. That was a lovely concept. And if the participants want to ask anything, please come forward. Ma'am, the Coimbatore region also is going through the same sort of rejuvenation in which a similar pattern is being adopted.
No, ma'am. There actually, as I said, they are very big lakes and all. So based on the lake influent characteristics, we use it. So in one of the lake, we see majorly industrial effluent is coming. So there they're going with ETP. So the solution is not fixed actually. It's based on what is the BOD, COD existing, what kind of wastewater is coming. We select the treatment technologies. Like in this Bangalore case, your BOD was very less. Let's say 150 to 200 was there. So for that, we went with nature-based system. So when we know there is a lot of chemical waste is coming, then we go for ETP. So based on the wastewater characteristics, we select this treatment systems.
Ma'am, what is the performance efficiency of these type of systems?
Okay, typically these systems is in the range of 85 to 90%. The 10% we allow because water body comes with a self-purification capacity. That 10%, let's say 10 to 15% will take place because of the dilution effect. So up to 85 that you can take that percentage removal takes place.
Thank you so much, ma'am. I think I was the most curious person.
Yeah.
So I request the participants if they have any questions or if later in the later case, if you want to ask anything, please get in touch with us. We will surely forward your query to Rohini ma'am. She will definitely be glad to help you out. and being such a wonderful and down to earth person. Ma'am, we thank you for taking out time from a busy schedule and coming towards us, bringing your experiences, sharing with us, and definitely inspiring us to work in the direction of water treatment.
Sure, ma'am. I think there is one question from Chaturvedi sir, probably. Maybe he's switched on the video. Sir, you have any questions, sir?
Ma'am, sometimes he likes to be like show that he's paying attention a lot.
Okay, okay.
He's attentive, that's why he keeps on switching camera. That really motivates us that at least someone is hearing.
Sure, ma'am. Sure, sure. Okay,
Thank
ma'am.
you.
Sure. Thank you so much. Yeah, any questions that you, I'm happy to, answer. Please write back to us. We'll help. I'll be able to answer.
Thank you so much, ma'am.
Thank you, ma'am. Bye bye.
Bye. So with this, we end the day 4 of this wonderful session by Rohini ma'am. She is a field worker, uh, practically working towards the lake's rejuvenation, and the way she was handling the projects was really great. I request the participants to please interact because that's what keeps us motivated, and it really makes a lot of difference and makes the environment feel lively. So tomorrow we will be starting at 10:30. Tomorrow there will be in all three sessions or technical sections, but two speakers are from the international background. At 12 p.m. we will be having a speaker from Qatar, and at 3 p.m. we will be having a speaker from Malaysia. So because of that time gap, we couldn't manage 4 sessions tomorrow. So in all, there will be 3 sessions, and in between, we will have try to have an interactive session with the participants. I would request you all to please participate and switch on your camera during that session so that we can at least interact with each other. So thank you so much. Looking forward to seeing you again tomorrow. That's all for today.